I'm back. Sorry, I have a fan today. Alright. I'm gonna try a stream with no music. See how it goes. I've seen a bunch of programming streams that didn't have any, and I thought they were nice. Okay. So I'm mostly gonna waste time tonight, but it's gonna be on something that's pretty fun. Let's bring that here. It's for later. Cool. I got new layouts on my side. Okay, so I got this algorithm that I got working, which finds the shortest path. So this is based on the same, or actually it's based on the same algorithm I showcased a few years ago, 2019 I think. But I got a new ideas for how to code this. Let's just look at what I did a while ago. Finding high-level overview. So I had this. Whoa, that's 2019, right? Yeah. More than 2 years ago. So is it loading? Okay. What's going on? It's possible that my internet is not very fast. Pathfinding. Oh, that's funny. I used to do this for my goal. Hey, John Games, how are you doing? Got you. Yeah, exactly. I'm looking at I'm mostly gonna be wasting my time. So I'm looking at this this algorithm for pathfinding. Hey, welcome, Eranku, welcome back. You've probably seen this before, right? My thing. Hey, think of them. So I've been thinking about my whole thing. Like I've been remaking my map editor. Let's say I put this here and I put this here. I've been like remaking the way that things are working. So now it's I can move things around. Let's say this is there and I move this away. You see how it updates? Yeah, this is really neat. Yeah, this stream is gonna be me wasting my time just playing around with stuff. I wonder if it's really shorter to go through the bottom like that. But at some point... Hey, let's do a little test really fast. Oops. The cost is not that bad, especially for the type of game. No, it's not. It's C#. New from the board. And let's do the other one. Whoops, I'm supposed to do that. Okay. I want to see if the path is truly shorter. Hey, welcome back, C7. Did I figure out the pathfinding through time? Sort of. I stopped thinking a bit about it, but I think I had a solution, or close to it. Okay. Right now I'm mostly rethinking my implementation, so I don't know if you guys saw this video, but essentially the way that I do my pathfinding is I would divide the space in horizontal areas and also vertical areas like this, and then together they create like nodes. Hey, nice, thanks. Yeah, and I don't have glasses anymore, so I've become more Superman-y. Yeah, so together they create these sort of optimized nodes. And I think I show it later, but each node still has the information about how big things are. Where did I put it? Oh, maybe later. Oh, right here. So you see how when you're in this area, you have like the information, this red. And as you're moving through this terrain, am I gonna do something? Come on. Click it, and yeah, things are updating. I have yeah, pretty much it's not really X-ray as you're thinking, but I see through time. I can see the millions of people watching this video in the future. So how do you guys like this? A fan instead of music? I guess I have a more ambient stream, right? Use power. Ooh. So what am I talking about? I forgot. Oh yeah, that's so cool. Wait, did I really say that around 9 years? Wow. Yeah, okay, anyway. So I thought about something else instead. Very ambient, yeah. Oh, but first things first, can I, how do I measure distances? Damn, do I have to do triangular? What's the trick? Is there a way to measure distances in GIMP? Oh, there's a measure tool? I've never used that. Measure. Which one is it? Airbrush. This. Whoa, GIMP has a measure tool. I've never seen it before. Oh, that's so cool. Oh, that's not how it works. Good. I drag. Whoa. And where do I see 502? Oh, that's so neat. Does Photoshop have the same thing? Wow. 500 pixels. Henry, what is Henry? Wait, I have to go check Photoshop. I guess it does have it, yeah, of course. Okay, so first things first. Let's grab this notepad. And I'm gonna write 500, sure, 0.5. First line. Can I just draw like this? Nice. Slam into New England and just kind of hang out before going back. Oh, Henry is the storm. Ah, I see. Alright, what is this? 217. Okay. Man, I wish I knew about this years ago. What is this? 143. Yeah, that's good, okay. 143.9, sure, whatever. Okay. It has to just be close enough, so whatever. 201. All the way here, roughly. 153.4. Okay. Total. Uh, 500.5 plus 217. 143.9. 201. 153.4. I end up with this. Okay. So this path doesn't change. So now, is this path shorter? Yeah, because when I lowered this, okay, let's see. Oops, I'm supposed to drag. Tropical storm. I wonder if I'm catching the tails of the storm here. Well, I guess I messed up here. The result should be the same as earlier, which was like 505. There we go, 505. 5, okay. I'm just measuring it just so that I know if I can claim that I get the shortest path or not. That's good enough. 400.5. It could, but I don't. I guess, yeah, that's a good point. I should add that maybe. Yeah, it would be trivial to add the distance. What is this? 201? Oh, that's good. The two distances are the same, so that's good to see. What is this? Something like that. 202. 202.4. Okay, what is this? 5.5 plus 408.5 plus 201 plus 202.4. Huh. Rip. So I guess I don't get the shortest path. I wonder why it does that. Why does it switch like that? Oh well, it doesn't matter. At least now I know that I'm not crazy. Because sometimes I was thinking that the path was not the shortest. Okay. Anyways, so here's what I'm working on, or thinking about. So I ran the algorithm manually. So let's say I have this terrain, and I start here. So in my pathfinding, this would be like the current node that I put in on the open list. This green dot. And then I mark the top, the bottom, the left, and the right. Essentially that creates, oh, I'm lagging, the boxes a bit like before, like these things. So right now it's in here. It's kind of funny that I'm using the same colors. Huh. That was not on purpose. Yeah. So yeah, so when you're here, you get this left side, right side, top, bottom, which gives you this big box. So this is pretty much what this does. Then let's say you move this green dot to the next one. Poop. The difference compared to before that I'm thinking about would be you separately track all those points, and then you keep for the right side the minimum, for the left side you keep the maximum, and then the other ones you have minimum, maximum, something like that. So right now I'm here, but my box that I'm tracking would be this. Let's say I move my dot here, bam. Now since this green escapes the red sort of part of the box, essentially I end up to the right of this red thing. Then something happens and it allows me to find this corner. So then since I broke this side, then I can find, then I update this, so I end up finding this edge. Let's say I keep moving, bam bam. Here nothing happened. Oh, that's a mistake. Okay, well this was before I understood what I was doing, but normally this here should be pointing to this edge right there. Oh, same thing with the first one. This one should not be there, it should be pointing here. Yeah, anyway, ignore that. Bam bam. So here, this should be pointing, this red one should be pointing here. This one is okay. Bam bam. Nothing happens. Bam bam. Something happens. Okay, let's use one that when I understood something. This one also broken. Let's see if I did this one correctly. If I understand this correctly, I can then code it. Nope, that's wrong. Yeah, this one is wrong. Do I use because I'm selecting the one under. Okay. What does this look like? Oh, this one is wrong. Because when I'm here, this one should point here. Sorry if this doesn't make too much sense. When you see one that is done correctly, it will be obvious. Let's see, bam. This is wrong. They're not really wrong, it's just that I was looking when I did those scenarios about different things. There we go, now we have the first real one. There we go. Bam, so if I start here, I get this length and this height. Bam. Oh, this is wrong. I almost understood what I was doing. Okay, let's go to the next one. Some of them are... Oh, let's go. Yeah, I was developing my visualization better and better. It's not actual pathfinding, I'm just like moving randomly. Anyways, so I have this left, right, bam, bam, up, up, bam. I think this one will be correct. Oh no, it's wrong. What? Okay, this one I think I understood what I was doing. Bam, bam. Okay. So we start here, get the whole length, move here, bam. There we go. So since this one is technically higher, we don't update this sort of pointer thing. But this one, since the height, the top is equal, then we're allowed to update it. Okay, keep going, bam. Now we break out of the vertical. So then we move this further. Bam. Okay. Oh, and since we broke out, something happens, and then we find this rectangle, this corner rather. Bam. Okay. Now we keep moving. This one gets updated because it's equal. Bam. We break out, find a new corner. Bam, keep moving. This is still equal, so we keep moving. Bam. Oh, what happened here? Bam. Both are equal, top down, so both get updated. Bam. We move up. Nothing special happens. Bam. Ah, we keep going. Nothing special happens. Bam, we broke out of the red. So this one, you didn't break out of it, so it doesn't move. We only move the one that got invalidated. Bam. And then we find this. And we keep moving one more. Bam. We find this one. Oh yeah, let's just notice. Ah, that's funny. Yeah, that's true. So when you move from here to here, you update the bottom because you're in something smaller. So by going through this path, I think that's roughly what I did. I end up finding 3 purple corners. Yeah. All those that are technically that are going to be relevant for that path. So the ones down here didn't get found. It's really interesting. Bam. Find this one. Let's try another one. So these ones should all be correct. But what is this? Nothing happened here. Oh. There we go. This one should be fun. Okay, so we move to the right. Bam, update. Bam, update. Nothing happened. Boop, down. Break out of the vertical. Bam, update. Perfect. Bam. We broke out of the red. Bam, we found this corner, okay. And also we update. And then we find this right here. I go down, what happened? I broke out of the vertical. So I found this one instead. I also found this corner. So in the order, I found this, then this one, then this one. Interesting. Oop. Most likely those paths would not be possible if you do an actual pathfinding with an heuristic. Anyways. So here nothing weird happened except we updated the bottom one because it's equal. Oop, we go up. Nothing happened. Oop, we go to the left. Bam, we find this. We found this because we broke out the horizontal red one. Bam. Update. True. Okay. Perfect. Perfect. We found the corner because, yeah. Oh, also the blue one got updated because this one is above the bottom one. Okay. Oop. Now we break out of the vertical one. Bam. Find this corner. That's really cool. There's something satisfying about the way everything gets found. Bam. So now we break out of this horizontal. Bam. Find this corner, update everything else. So cool. And that gives you a path like this if you... Yeah, interesting. Hey, peace. Finkelum. So I like this idea of tracking every side separately. Oh yeah, I don't need this for now. Close that. So yeah, I was doing this thing Pathfinder 2, where I was starting to think of my nodes. Now there's a lot of things. Hey, check it out. I found a bug in the C# syntax highlighting TextMate. When you don't have the comment here, you have bad syntax highlighting. Pretty funny, right? They somehow messed up their regex. You can also fix it with a parenthesis. Okay, so I was thinking of tracking each side like this, but maybe that's a bad idea. I might have to do an actual pointer to a previous node, one of those nodes. Which would be a previous node from the path. Something like that. Node, bound. So instead of doing this, and parent is what? It's a node. Parent was me, and this has a node. So what is node here? Oh, that's interesting. Right. So what is bound? Bound is a rectangle. So you want to do the check, but you don't want the result. You want the node itself. And the parent. Oh, interesting. Okay, I don't know if this stream will make much sense, because I don't know if I understand what I'm doing. I have an algorithm that works, so I don't technically need to do anything. But I feel like this thing is just so cool that I have to try implementing it. See if it works. But it seems like it does. It's so cool when you do this. Like the way that the way that this is a straight line, and you see the line divide in two, and then yeah, this is so sweet. It's really satisfying. Let's disable that. Oop. Yeah. Okay. So what do we do? Do we do a bunch of if statement? Essentially depending on at the point that you create this node bundle thing. Hey, I'd really like to have better words actually, instead of this. And node bundle and proxy cost, they're all made up words. Let's relearn pathfinding. What was this site? I think Red Blob or something. Yeah. Did they give us words? So you have a graph. You have nodes. And how do you call like a node that you visit? What is an open list? Open. Oh, did they not call this list? There's no list here. Interesting. There has to be. How do you implement a star without having the word open or list? What was this? I'll close. Oh, they called it frontier? Until the frontier? Oh, what? Instead of saying open, they call this a frontier. Interesting. I've never seen that. Pick and remove a location from the frontier. Oh, they call it a location? Huh. Frontier is a queue. Yeah, fine. Okay, fair enough. So I guess location is a node. look at the Wikipedia entry instead. Yes, fill, yeah. History, good. Description, okay. A star is, starting node of a graph. Pointing a tree of paths. Originating at the start node. Okay. Yeah, came from start goal. Open set. Open set is what? It's just a list. A list of. Oh, so they don't save anything extra in here. If a node is reached by one path. When a node is removed from open set, the path to it is guaranteed to be optimal. So the test tentative if the node is reached again. Oh. That's always true if you pick your best node. Yeah. I'm just trying to relearn this from scratch just to make sure I don't have any bad assumptions. Implementation details. Oh, they use this? Oh, interesting. Yeah, I guess that's true. Infinite graphs with non-negative edge. Yeah, that's the applications. Yeah. Okay, that's not what I wanted. Let's look at this one. That's an implementation. Alright, so in this you have the point itself and then the node. Those are the words. Yeah. Set that. Okay. That's the reset. Thin height. I really like C and C++ sometimes. At least when it looks like this. So A, B, allow. Nice. Yeah, that's funny. Multiplying it by 0 to negate this. Yeah. Smart stuff right there. Start grid, destroy grid. I almost skipped that. So you get your thing, input, output. Star output T. What was input? Oh, it's not defined here. Huh. is CTP? I'm guessing there's a header somewhere. Library include this one. Okay, I start input. Output. XY, okay, that's interesting. I wonder why it's defined like this instead of just using a point like that instead. Each element, yeah. Yep. A star output. So you have an array. Oh, they're always separated. Yeah. So that's the structure of arrays. I feel like there's not really an advantage in separating them like that in this case. So a star. So what do we do? Start your grid. Does that do a copy? There's no way, right? Okay, grid reset then. Open list, true. Oh, this is where he makes his point. Okay, S, start, E. Okay, everything is copied here. Allow. Very funny. So get the nodes from this grid. Sell to cost. Okay, good enough. X. Oh no, it's from, yeah, never mind, it's from output. Yeah. Okay. Maybe I should remember this optimization. I could do it myself. Alright, so YW index. Okay. You find where you're at. Very smart. Yeah. Initial, very cool. So we start at 0. Mistake, initial, age. Set it to true, push it, and then the magic happens right here. Wait, am I reading this? No, it happens in the whole thing all the way down here. Okay, perfect. Why do you return false? Okay, you have this right there. Okay, that's the short circuit. Yeah. So the algorithm then is here. Very clean. Sell to cost. Yeah, continue. Yep. Where's the code that finds the neighbors? Oh, this? Wait a second. Oh, it's defined here. Okay, I thought that code looked weird. So you queue it like that. Okay, next. Node with, yeah, okay, perfect. Cool stuff. Yeah, yeah. So once they're queued, next count, this gets incremented. And it gets reset every iteration. Okay. And what's the while? If you still have stuff. Okay. Yep. So we're gonna loop, let's say 8 times. Okay, I guess I'm happy with that. Okay. Mine is slightly different though. Okay, let's go all the way back. So for what I call a node bundle, instead of node bundle, can't I just call it a node? I don't see why not. Just a node. Oh, but then I have a clash. Okay, fine. Hey, thanks for a follow. Origin backwards burn. Welcome. Alright. So how many lines is this? 300 already? And I didn't really start. Right, I forgot. That's true. This has the same thing, right? A, B. A. So you get the distance from that to that. Yeah, yeah. To the end. Okay, yeah, yeah. Same thing that I have. Perfect. First cost to tail. Is that really what I want to call it? I guess it is. I'm using the words head and tail. Hey, thanks for a follow. 4 gators. I don't know if I said it earlier. Okay. So I'm trying to think of the right way. I want to be as lazy as possible here. So if my parent is not null, let's think about this. I save myself iteration. Yeah, okay, if I check correct, let's just do it long way and then we'll figure it out. So if does not equal null, then we have pretty much another if. If it does not equal null, and we don't need to do the max. If it's not null and we want to keep the parent. If the parent dot left, but left is now going to be a node. Essentially we want to come back all the way up to this node. So left is what? Wait, left is the node. Oh, right. Okay, bound dot wait, but now we don't care about bound, do we? Wait a second. Well, it does make things easier to think about because we're like mixing horizontal, vertical. Should I just get rid of bound? Not really. It makes things a bit easier to think about. So if this is what? If my parent's thing is bigger than node, like that, we don't put equal here. Then we do my left is equal to parent dot left. That's it. Otherwise, left is equal to the node bound dot left. Oops. Never mind, this is misleading. X and A, yes, this is monogame, but it's pretty much the same thing. Hey, welcome, 5X. Check it out. So I got this pathfinding algorithm that works in continuous space. And I'm able to update the terrain and just see how the path updates. I really like to make a big one here and then you shrink it. Let's put this there, this there. It's not that bad. I find it actually simpler even. You're new. Oh, but you want to learn it? It's a very once you get the hang of it, it's very lightweight. Just starting. Like let's say you want to start a new project. You get your .NET. You install the templates, so the monogame C# templates. You install the pipeline if you need it, and then just creating a new game is this one command. Every time you want to create a new game, change this, and then all the basic. Yeah. So getting started, publishing is incredibly easy. Yeah, it's a mess. It's a mess if you don't know what you're doing. But I really like the way that I set up my stuff. Like you see how you have like your game class, then you can set up a few things in the constructor, very lightweight. Initialize, you do your Windows stuff, and then when it's time to load your content, then I do things like load my settings, set up my window size. Hey, thanks for a follow. bunch of things, set up my camera, load my fonts, load a bunch of other content like my textures, shaders. So I really like this top-down view. I set up my UI, my world, my editor. Bam, everything's set up. So it's very easy when I have a bug to know like where I need to go. In my update, I do things like update my UI, update my my editor here. Yeah, this is a custom engine. I do that in every game that I do. Like it's always, it looks similar. When I draw, here I draw my FPS, so you can see FPS up here. Oh no, this doesn't actually draw. This counts the FPS. The actual FPS is down here, drawstring. So I have things like draw my background. So you see like all this space stuff. That's drawn like right here. I have a bunch of things like a shader that draws my background infinitely. I have things like draw my editor, bunch of things. So the grid is drawn here, draw editor background. So you see all these grids. It's drawn right here. So I like to do a bunch of things like that. Do my grid stuff. Yeah, you need to trial and error. Then I have things like the actual game itself. So this has the camera view, draw my world, draw my editor stuff. Yeah. So this whole thing is custom engine. Too fun. Okay, anyways, let's see where I'm at. This thing we don't care. So now I got, I think, what I need for the left side. So if my parent's left is bigger, we keep the parent. Huh. Yeah, I guess this works. So we'll do the same thing with the top. Oops. I guess that's what I'm supposed to do. It's kind of weird. Top. I'll have to find a better name, I think. I'm trying to implement my custom pathfinding algorithm. The right has to be smaller. I really can't wait to see this in action. Bottom. There we go. This whole thing gets deleted. Okay, can I get better names here? I could just call it left node. Manage scenes. Oh, yeah. I don't tend to break my head on scenes. I think of them as like modes. In a lot of my games, the way I code scenes is like this. I call something like a mode, and I'll have ignore everything actually. I'll have a thing like a setup phase. You can think of it like a constructor. Update setup, update input, update cleanup, cleanup, draw UI. This is like the life cycle that I put on my scenes. Everything else you can ignore. So you could call this an I scene, and it could be an interface instead. So essentially, setup is what you call at the very start, and it's only called once when the scene gets created. And then during the loop, I call update setup. This sets up everything that at the beginning of a frame that needs to be updated. So let's say you have a UI, then you can update your layouts. Then I update inputs, and then update here. Update can be used for things like animations. Everything else that doesn't in a frame rely on inputs. Or things that, like let's say you decide to stop calling inputs, you can still call the other two, and your game will still start work. It will still be fluid. Yeah. Oh wait, let me check. Find all references. Interesting. Yeah, so when I call cleanup, so I guess I call setup. I call cleanup when I switch to a different scene, and then I call setup. Yeah, that's interesting. Maybe you can do something simpler than what I do. This is kind of hardcore, I guess. Okay, recompute costs. Okay, so do I have wait, how in oh, did I close everything? Rip. In here, how do you keep track of the parent? Oh, it's here. Note T, right. Parent. Interesting, okay. Let's make a space here because those are like separate stuff. Those are things to make yeah. Alright, so now I have access to the corners. Top, left, top, right, bottom. They all get updated and automatically as the node work. Oh. New parent. If I change the parent, then I change the node. Huh. Alright, let's do a private here. Private void. Something like that. If I already got parent, parent is here. Perfect. This whole thing. Oops, I went the wrong way. Let's put that down here. What's wrong? Node. Node is not node. Node is that. Okay. Oops. Okay. So if I do a new parent, I'll do the same thing here. Set up nodes. Don't need a space there. Why are they not happy? So they don't understand that I went through this. Let me try this. I feel like they downgraded the C#. Huh. I don't remember that being an issue in the past, being able to initialize things in a function. Let's see, so what is this, the error? Before. Let's read this. The compiler. Yeah. The compiler is so dumb. If I build, is that the same issue? .NET build project platforms. I guess that's not how you do it. I don't have a release here. How did I do it? .NET pack. Oh, you just give it. Okay, I see. So they really do. Even the... I get it right. Okay, anyways. Okay. I forgot how to tell you that I don't care. Oh, I like that. Hey, thanks for a follow, Crabnet. Welcome. Alright, so at least I have this. I think this code is okay. Not null. If you're bigger, keep the parent. Alright. I wish I had better names for all these. Node bundle, I kind of hate it. But like it feels like everything is a node. It's like nodes that have nodes. I don't know of a better word. Alright, so when you set that up, bam bam, the cost, things are different. So I'm sort of designing this algorithm from the bottom up. I really dislike doing that. I once wasted months doing an algorithm like that, bottom up. It's much better to do it top down. So is that what I should be doing right now, top down? There's a lot of room for improvements. Okay, anyways, let's read this. So you start this. What do I do here? Horizontal. I create two nodes here. End node. For this, I have an equal, right? You're equal if you're in the same zone. Yeah, okay. Oh, and also hash code of this. I implemented that myself, right? Yeah, based on the rectangle. Okay, fun. Alright, so first node, you give it your start node. This is now wrong word. We call that the head node and the tail node. Okay. And instead I could call this the head bundle. Bam. Hey, welcome, Fire. Hey, how are you doing? Head node. A wind tunnel, yeah. So I decided to, instead of putting music, to just use my ambient fan because it's so warm. Doing pretty good too. I'm like having fun with this type of pathfinding algorithm. It works in real space. Free space, rather. It's so cool to see how it behaves. something satisfying about this motion. Are you a game dev? You've been here before, right? Internship, still in school. Hey, thanks for the sub, 5 kicks. Yeah, C#. It's a pretty nice language. So yeah, I guess I reduced my whole algorithm to this single iteration. Backtrack and git path. Yeah, same here. Started with Java. I used to think Java was a good language, but wait, so this sub message has a ban button on my screen. That's so funny. Well, there you go, get a sub, get banned. Alright, single path iteration. What do I do? Get best node. For now, like, this whole thing is badly implemented on purpose. But the big lines are here. That's all that matters. So you get your best node from the open list. Full cost. So here with the F. Should I use those names? H, G, F. It's so tempting because this is so standard. F. Why should I not do that? I guess F is F. Cost to N is the G. No, it's the H. Simple travel cost. Why did I call it that? How is this one coded? This one has a travel cost. Oh man, there's so much complexity here. Barrett, the best Barrett. Yeah. Yeah, there's so much stuff here. I don't even understand how this works anymore. It's been 2 years since I coded those types of lines. I know that it works somehow, but it looks like magic now. This thing somehow pretty much powers the whole thing. Wow. Nice. Do you have a game you're working on? Something specific? I'd say like a good way to start would be to do simple stuff. For example, if you need a UI, hard code the UI yourself. Like I do like some actual checks, like if the mouse is inside of this zone, then you're on the button, and then if you click, so you hard code everything. That's how I think it's the best way to start. You don't think about anything. You do the shittiest code, hard coded everything, and then over time you learn how to do different levels of abstractions. So like you start by hard coding. What's my plan for the pathfinding? So here's what I'm working on. So I have this is the final algorithm. This is my old implementation from 2 years ago. Oops, I didn't need to do that. It's very responsive right now. I can move things around and have the shape update. So if I, alright, oops. There we go, you see, so I can move the terrain, and so this is what I have. It's a real space continuous pathfinding. My plan is to see, and I had a video a few years ago, 2019, where I explained what I'm doing. The main idea is that the terrain gets divided vertically, so I get strips that are vertical, and I also have strips that are horizontal. Let's move that here. Together, it creates like different zones, or essentially my nodes. Oh, that's funny. Yeah. So that allows me to have non-grid based. I don't have to be aligned to a grid when I'm doing my things. Like I move my things around, and I get this. The space optimizes itself. So you see, when you have one big rectangle, the terrain has no complexity. So you see. I have this. So you see this yellow thing, I can actually use this to move around my nodes. So you can sort of see how terrain is designed. Let's do another one like that, a big one. It's really cool to see how the optimization happen. So essentially what the pathfinding does, the old version was those nodes, the yellow things, are the intersection between the horizontal stuff and the vertical stuff. And then you can use your knowledge of the terrain. You see how this one is this wide, this and this high. Yeah, non-standard. And then if you go here, you see this is this high and this wide. And if you're here, this area is this high and this wide. So you sort of discover the corners. You discover, for example, this corner right here. That's because you're like, let's say you start down there. If later your character ends up outside of this red box, then that's how you're able to find the corner. Oh, I guess I'm gonna click here. Bam, you see? So something happens when you escape these big boxes. So that's how I was thinking about the algorithm in the past, but I figured out a different way of doing it. And I'm going to try to implement that. And instead of thinking about them in terms of big rectangle things, I want to isolate the horizontality and the verticality. So that's what I did here. So let's say I start in this square. This whole region is this high and this wide. then I move to the right, bam. Since the height here is the same, then I update this pointer for this node. Then I move, bam. So nothing happens, but we're still updating where I'm at. Now when I go down, something weird happens. I end up outside this blue horizontal thing. Bam. So you see how, because I escaped this, I update this bottom pointer thing. So now it points to this place. Also, while we were at it, this left red thing gets updated here because this zone is further to the left or further to the right. Essentially, you're trying to shrink the area. Now I move from here. Oh, and by the way, because you escaped the blue part, bam bam, I found this corner. So it looks like I can find the corner by using the Y of this blue and the X of this red one. So both together give me the point at the corner. Likewise, if I move here up to here, I escape this to the right of this. Bam. So we update this right. Oh, and by the way, we update the height. And then also, from this X and this Y, we're able to find this corner. So the whole purpose is like you're moving around, things are happening, you're discovering through your path different corners. Bam, bam, bam. And then you can do a sort of line of sight thing where you can ignore all the corners that are not like in your line of sight. I skipped a lot of detail. Everything. Yeah, exactly. So finding the corners gives me information about the terrain around the path that I'm walking in. So as you travel, so because of the way I design like vertical strips and horizontal strips, every node becomes meaningful. Every time you go from in a different node, something is happening. Because nodes can only exist where there's something meaningful that happens in the terrain, just because of the way they're done. So like here, this whole area, there's nothing that happens. So it means that I can have this bigger node. While here, there's a bit more details. So this node is smaller. Yeah. So like in places where there's more details, you end up with a lot more nodes. You see that there's a lot more stuff going on. So let's say I move, you see how there's yeah, this is for pathfinding. Yeah, for game purpose. In the future, I think I could use this system for doing physics. Because I have a lot of information with this setup about the geometry of, or like the positive space where things can happen. So I think I could be able to use this for doing physics. I don't yet know how it would work, but I think it would. It feels like it makes sense. Also, if I wanted to do like another type of game, like an RTS, where maybe you have very narrow paths. Like let's say this is your path right here. Maybe a unit would be too big to go through here. So maybe they'd have to go through a bigger path. Like let's say it's there. Let's hide all that. So yeah. So maybe it's too big, so it would have to go above. I think I have enough information in this to know if something, like if a path can be filtered out or like completely ignored in the pathfinding algorithm. I'd like to play with that someday. Anyway, for now it just assumes that you're infinitely small, so you can go everywhere. So cool. Okay. So I use this for all my navigation. It's pretty much my navigation mesh. And this C# code, it's like the exploding brain meme. Okay, what am I doing? So I want to go. Yeah, it's still somewhat A star, but there's a bit more steps involved. But so there's in one way it's a bit harder to find the path just because you can go at any angles. But in another way, your nodes are a bit more. Well, I mean, A star could just pathfind over that, but just like the space optimization part is interesting. So it's not just like you're going through a grid. You really have something. If you were to run A star on this, it would be faster than having like 1,000 different grid cells. What happens if I do this? Wait, what? Interference. Oh, wow. There's electricity in my tablet, so it does. The mic can catch that. Huh. I guess it does something to the electronics in my mic. I'm guessing the stream caught the little sound. Okay, what am I looking at? So I get my head, tail, create your node bundle thing. First proxy cost. How did we get that? Oh, okay. Proxy cost, incredible. Okay. Corner none. What does that do? Does nothing now. Okay. I guess I deleted so much code that it's now not used. But it's sort of useful. If I look at the original implementation, how many lines? 400. Not too bad actually. Corner. Wait, what? Wait, even this one doesn't. Wait a second. Wait, so I do so much work to get this corner. Oh, it's used, but it's not used directly. directly. So corner is something, but it's get corner. And this is man. Oh sorry, there's so much crazy code here. Oh man, ouch, my eyes. So you're telling me that I'm allowed to just delete this and nothing bad will happen? Wow. Yeah, well, I already know it. Let's get rid of this. I mean, I understand what I was going for. And I feel like it should be used. What was this? None? yeah. And where's the other one? Here. This thing gets put there, but it's never used ever again. Item 2 becomes current corner. Can I name this? Am I allowed to do that? Hello? Give me some feedback. Why is there no name clash? Come on. Oh, because it names it inside. No, it doesn't. I don't understand. C#. There's so much stuff in the syntax. Let's restart. So restriction corner is used here apparently. Yeah, I guess that makes sense. Yep, it works. That's so cool. I can get it a straight line right there, all the way through. Yeah, this is so awesome. Yep. Do I commit this? It's kind of scary to remove that. Because I understand what I was going for. Because a proxy cost ends up being a corner. So knowing what type of corner this is, isn't that valuable? Or is it just useless? Like this is not the same corner as this. I guess in practice it doesn't matter. because the corner information ends up becoming part of this other thing that I call a restriction, where you have A, B, C, and that's what determines corner. Yeah. It's like this sort of line of sight thing. Oh, there's nothing here. I'm just memeing right now. It's a valid optimization, but I don't know if I want to commit that. Because this is my old crusty implementation. If I could... yeah, I did XNA with the Visual Basic Language before Monogame. I wonder how I found XNA actually. Yeah, if I could get rid of all of this get corner position thing, I could get rid of all of this. Oh man, yeah, this thing. With my new algorithm, what I'm hoping is that this whole thing will not be needed anymore. It will be more surgical, my new thing. So proxy cost. So I have this thing called a restriction, which is pretty much a line. Then I'm able to say if you're above or below a line. Let's just look at this a little bit. So this gets found. This one gets found. This one would point to this though. Wouldn't it? I think so. This one would possibly also point to this. This one would point to the starting node. So wait. Let's go back. Let's say this is my starting position. In other words, when I find this corner, let's create a bunch of things. What color can I use? Use a sort of very grayish color, maybe. extend this line. Go down to 5. This is all visualization, just so that I really understand what I'm doing. Okay. There's one here. Oops. How do I undo rotations? Okay. So you're gonna go all the way there. Bam. This one goes all the way there. Bam. This one, I think. Oh, that's interesting. It doesn't go there. It goes there. Huh. This one goes where? Oh, straight here. So yeah, I'm trying to understand the connection between everything. This one. This one also ends up here. And the last one ends up here. So that's why, yeah, you end up with this sort of line. You end up with the path. Possibly easier to see. I wanted something that's easier to see, but yeah, sure, whatever. Okay, somewhat understand. So we add this to the open list. Current bundle equal null. Can this, does this ever return null? Get best node. This code is bad. I guess we never end up here because I don't allow you to be empty. Instead of not equal 0, this should be above 0. That was young me coding that. Okay, so single iteration. This can never be null, so this check is completely useless. Because if you have at least one, then you do have a value here. Because this would find something. Then you remove, make it visited, do your thing. If you find nothing here, then you're gonna return the current one. Yeah, I don't need to be doing a null check here. This is never null. It's not null, so they know because this is that. Okay. So current node does not, if it equals the tail node, then we're done. So then I do a backtrack. I'm gonna keep that just for now. I'd really like, the problem is that I need, essentially, I can think of those lines as having a normal. And the normal depends on, right, okay, wait, I'm starting to understand. Switch that down, couldn't care less. Okay. Bam. Bam. I want a nicer color, I guess red, yellow is okay. So when I find this corner, what you're doing is doing a line like an infinite line pretty much with a normal like this. When you find this one, likewise, let's keep it separated, it's okay. Other one, I guess I don't care anymore. Okay, so when I find this one, I have this line all the way, an infinite line, bam, with this normal instead, bam. Yeah, that's interesting. How do I know how this works? Squares. Hey, Schmilliork. Hey, yeah, welcome to the madness. Were you streaming? I don't think I saw you online, right? Earlier, nice, nice. So I'm trying to figure out this new like big brain pathfinding algorithm. So I'm designing it from almost scratch based on my research from a few years ago. This thing has been in their work pretty much since 2014. Yeah. And I think about it from time to time, and then I discover new things, and it becomes hopefully cleaner. Man, this is so cool. Bam bam. How do we have the normal thing? Bam bam. Bam. What happened here? I'm able to find the corner because I take the Y of the bottom, so that's the one that I broke. So if you break something, then you get a new, the x2. If you break on the y-axis, then you get a new x-axis. That's like a given, right? There's no... So after I update... But how do you know if it's the left or the right side that I'm supposed to use? That's a good question. Is it because this one didn't move? Except that it's not because it doesn't move. because it could have moved. Give me 1 sec, we'll do that again. This terrain. Let's steal it. This will become OSJ. Fine, I'll use J. Okay, restart. So I start here. Oh, that's good. Both are gonna move. Okay, wait, let's see. Bam. Bam. Now I move here. Bam. And then this points here, this points here. Now if I move down, now something happened. I exit this. I start with this. And then this gets moved for both. Yeah, so I guess that's not how you detect. Huh. So how do I discover this corner? There's something that happened and I'm supposed to find this. But how? I thought that was obvious, but now it's not so obvious. Finding the Y is obvious. Because it's the Y where I break it. So before updating, I preserve the Y. Bam, bam, bam. But what? And here it's not as obvious because both. So how do I know which side here I'm using? The left or the right? Huh. So let's do A. What's the difference here? And I guess I'll do GA. Fine, I'll put the A first. There's something going on and I can't see it right away. This is JB. JB0. We'll do the same thing. But we'll do from this side. I guess I happen to take a terrain that's really good for this check. Not that. JB2. So what exactly happened? still had this. And this is pretty much the same too, the same height. I guess it points somewhere else. Huh. I don't know if that's what I was supposed to notice. Bam. So we're gonna be here, here. Now we go down. And then, oops. And going down, something happened. Somehow I find this. What's the difference? How does going down here finds that one, but going down here finds that one? I guess I wasn't taking this. So those are drawn currently like a sort of bone, but the real visualization is like this. So let's redo this terrain. 1, 2, 3, 4. I guess I'll do 1, 2, 3. That would be easier. 1. Fine. That's it. Okay. Huh. So if I look only at this, so I find this corner. Is it because it's the bottom left of this? So I don't even need to look at the rectangles, at these rectangles. Is that what I'm supposed to look? I do all the discovery from a single from this corner. It would be so much more elegant if I could use the red one and not just the blue one. Let's look at the other ones from before, from like K. Is that what happened here too? Let's see. Kind of did. So this thing was this rectangle right there, this bottom one. So when I escaped it, I invalidated the bottom. Is that why I find this rectangle? So then I do like I check on this rectangle. Oh, if I invalidate the bottom, the only thing I can work with is the bottom left and bottom right. I don't even need to look at the two top corners. And then I can say, am I to the right of the right or to the left of the left? Is that how I find this corner then? Let's keep going. Bam, I found this. Bam. So what happened here? I invalidate this red one. So far it looks like it works. So I invalidated this one. This one is this big corner. I went to the left. In other words, I have to look at those two corners, the top right, bottom right. So I say, am I at the bottom, am I below the bottom one or above the top one? I think this is what okay, let's just look at my other examples. I might have to redo them. Not that one, not that one, that one. This one is good, I think. I should redraw it. Let's restart from scratch. Where did I go? I started up there. And I stopped there. Let's just get rid of all of this. D1. Let's redraw this with more accurate. Okay, this is a bit too far. Let's bring it down. Okay, so we're here. And it's this high. Bam, bam. Keep going. We end up here. Bam. Okay. So this gets updated. This one doesn't. This one we don't care. Okay. So far so good. D3. Something happened here. We got out of the red. Oop, it updates. And the blue here is lower, so we update it. So since we broke this one, we look at the top right, bottom right. So we're below the bottom. I'm assuming that's how I find it. And then I find this. Keep going. D4. We go here, keep going here. If I do this right, I'll have some very simple checks. Okay, so you're staying here, you're updated. Bam, because those are equal in. Okay, so nothing happened. Let's keep this drawn. Oops. D5. Okay, now both get updated. Bam, bam. We end up here. Let's preserve this. I'm trying to think of a situation that breaks this observation. But so far it looks good. It's not, I don't think this setup is the one that breaks it, if there's one. So you're staying there, updated down here. Let's go up instead of D7. So you get updated. Okay. And what happens here? It just gets updated. Bam, bam. We found this corner. How did we find it? We broke this one here at the top. In other words, we have to look at this corner, this corner. So are we to the left of this? No. We're to the right. Bam. So that's how we find the corner. Bam. I don't know. So far this looks logical. Yeah, it's so simple. Okay, do I have the skills to implement that? Let's see. So by the time we're done, we have this final bundle. Final bundle is equal to the tail. I mean, if that's the case, why not just write tail bundle? We don't care, right? Or is it called bundle tail? Oh, never mind. I guess I can do that. The bundle has the whole solution is in here. I can't just discard that. Okay. Trying to be lazy, but it's not that easy. Okay. So final bundle, you get this proxy cost true. No, I created a new, and I give you this final bundle. But yeah, when I give you that, you're gonna compute your best parent at that time. Interesting, very cool. I'm guessing I can do it better, but yeah. And then I backtrack, bam bam, I use the best parent. So I add your current position, which ends up in the tail. Add that to my result, perfect. Then you backtrack from best parent down to best parent, bam 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 bam. Okay. Yeah, this is so magical. Best parent. This thing, I can't figure out. It's been so long since I coded that. How does this simple recursive code ends up doing? How is it so powerful? And this validate is really. What's wrong? Button. This is so incredibly simple. That's like what, a dot product? I think. I'm really rusty in math. Oh. Get line side. Validate. So when I validate this. XY. And it gets bootstrapped by this I say this is bad code. It should be X, Y like that. Parent should be parent, Y. Yeah. I don't know, it's probably more costly to do that. Essentially those variables, I think it's okay to throw them out as fast as possible, as soon as they're assigned. Hey, by the way, welcome to everyone that's new to the stream. I'm trying to explain what I'm doing, and I feel like I'm starting to understand what I'm doing, so I can hopefully explain it better. This code is a bit of a brain twister. This is so cool. Get best proxy cost. This returns. So what am I doing here? I'm recursively going from PC. And when do you stop? You stop when you get back to null. No, when it's not null. At some point this becomes null. So then this becomes null, this becomes null, so then we exit. This is null. So then this is null. Then we go up. And we reach, yeah, so we're always having to backtrack. So for every new node, I'm re-backtracking all the way back. This is where there could be a good improvement to do. So I'll do it like that for now. This is somewhat expensive. How to wire going all the way back to start. So yeah, the best node really does end up becoming the best node. Oh, but it stops. Right, okay, that's the thing that I failed to notice. We don't backtrack all the way back to the start, because this could return, if this is not null and this is not null, then we might actually validate, and then this can return false. So then we just stop. So that's actually the escape hatch right there. Okay, that's really interesting. So it's not as bad as I thought then. Actually, it's good. And that's really cool. Yeah, I like this actually, now that I understand it. Yeah. So as soon as you don't validate something, then you just stop. Yeah, you don't have to look further. That's really cool. There might be a better way of doing it though. Maybe not. So we now end up with a chain of what I call a proxy cost. So each proxy cost points to a proxy cost parent. Right, that's so cool. But they also have the, oh man, that's so, okay. I'm able to start visualizing, and I see some really nice images of this setup. So then I never need C. Is that valid? No, that's not valid. If I can get to use this correctly, then it means that I can do my restriction instantly. set restriction. This is where like the big, wait, what? Oh, because I deleted all the code. This thing, I guess I'll just search like this. Yeah, this thing. So if I'm able to re-add this corner thing, I can get rid of this function right there. I can then get rid of this whole thing right here. If I can get rid of this whole thing, yeah, okay, I see. Set restriction. Yeah, A, B, C. In other words, when I find, let's say like from this rectangle, I find this top left corner, and I don't need to know that it's a top left. Like I know intuitively that it's a top left because I'm at the right. No, this is a top right because I'm at the right of this rectangle, and I invalidated the top. So then, if I want to find a dot, so when I draw this line, essentially I end up with a, yeah, sure, I'll use yellow, whatever. So then, so I end up with this proxy that goes all the way there. Let's just extend, sure, whatever. There. The normal is there. Bam. And then the point that I generate to find this normal is like somewhere here. Or is it? Yeah, if I follow the line, yeah. I feel like taking a point here is valid because the line can only go 180 degrees with this setup. Not 180, 90 degrees. So essentially when you reach a corner like this, you can come from many directions. So let's say you come from this, or you might come from this, or you might come from this, or you might come from this. If you come from further, then this corner doesn't exist. You never find it. So yeah, you only get this angle. And if I wanted to make this whole system more abstract, essentially you can say like it's an angle from here, or from, yeah, interesting. So let's say like this thing was not there, but it was like this. Then the maximum angle would be there. Further, and now you don't have a corner. Interesting. Anyway, with this setup though, I'm allowed, if I generate a point to the right of this corner and below, then no matter what, from this point, for this line I would find this normal, and for this line I would find this normal, and for this line I would find this normal. Huh. because the point is on this side of those lines. For example, if the point I was to pick this one, now it breaks the whole thing, because now this normal is here, this normal is here, but now this normal is here. Yeah, okay, I see. So by doing this, I get a really simple system, very easy code. So the old code to do what I just explained was, it was this ugly mess. Get corner position. Oh man, this was so bad. Look at this. I create this thing. It's what is that? An array of float corner. A corner is wait, what? Wait, since when does that do that? What? I guess I'm looking at the wrong one. What? References? Fine. Where did I define corner? Corner, here you go. That was weird. That's a weird interaction with go to the implementation in a tuple. That's really weird. Anyway, a corner is top, right, bottom, left, top, right. Wait, what? Top, right, bottom, left. Those are not corners. Is that used anywhere? That's so bad. Oh. Yeah. This code, no. This will all be fun to delete. Anyway, look at what I do. I define this sort of tuple, float corner. So float, here's the left, right. Corner is left, right. So those here are like the, I guess it's an int actually. Wait, for real? I convert my int to float. Back to int. Oh no, I guess it's okay. Float. Yeah, who cares? Okay. Anyway, so I do this thing, I add them to these sort of arrays. I sort the arrays. I do something about I don't know what. Direction, sign. Find spot in list, which is what a loop. Oh man, it loops 4 times. What? Oh man, something. Corner orientation. So are we a top right, or a bottom right, or a bottom left, or the whatever the last one is, bottom right? Oh, and it's inverted. But so a top left gives me a top right. Wow. And then I return that. Yeah. Yeah. I hope I never see this type of code again in my life. Yeah. So this new thing would make this so much easier. Okay. So what am I looking for? Okay, I'm going back to the top. Wait, what is this? This corner, get wrecked. Yeah, there's no more corner, nothing like that. Well, sort of though. I guess I can keep corner. Get rid of that error. No more error. Bam. Okay, those are the only corners. But why would I do that? When I move, I discover those corner things. I guess when I do, wait, how did I find them in the past? This would be when I do a new. proxy cost. So every time I do new proxy cost, what? I only do it twice? How? What? Okay, I understand nothing anymore. I'll have to follow the algorithm. Oh no, I'm looking at the wrong file. Oops. Okay, that makes more sense. I can't even find it. Okay, give me that. Find all references. There we go, 3 times. This one is not the one. This one is not the one. I don't understand why it doesn't put them in the right order. Anyways, yeah, this is the thing that somehow figures out. So when we end up here, so yeah, the shape of the algorithm will be completely different. Okay, let's keep going then. So single path iteration, get your best node however you want to do that. Remove, add, and now we end up with get horizontal node. So the thing to the left or the right of this current bundle. And here the things that are above or below. So I separate those two. Let's start with horizontal. So going left or right. This thing I know works. Add if new. And now here I create this. I think I can simplify that. Because what does this do here? Find if it exists. Find node in list. Yeah, I think I should skip creating. Instead, you should take your vertical and horizontal. These value, just pass it to this function. Node. So here we don't have a node. We have a horizontal, vertical. That's what I'll use. Everything else I don't care. I'll do the same here. If we need to, this is where it gets created. Horizontal. Okay. Cost to end. We don't need that right away, I guess. And now find a node. You don't take an existing node anymore. Or do you? Where else do I use this? Find node in list. Yeah. Okay, I use only 2 places. Okay, that's good. So yeah, I don't need this at all. Horizontal. Okay. So now I can't do that. I might add a little function then. So instead of equals, is the word is restricted? Or I guess I could just use equals anyway. Public bool equals kind of wish I got autocomplete on that. This would be U. Something like that. Could use a different name, but whatever. Okay, horizontal, vertical. Just rename that to just bundles, because why not? Okay. So now, oh, this one too, I'll put it down here. Now this one, find node in list, we just give you horizontal, vertical, node to end. So now we might find something. If we don't find, so this might find null. Okay. Do I do it like this? I guess I'll do it for now. If it does not equal null, we'll do it like that. So you're called node. Oh, it returns the bundle. Was there something special here? Add if new. Cost to n was never used. If this was null. Yeah, so cost to n, we don't care about it then. You're gonna do something here, so if this is null, we don't care about many things here. Okay. So in that case, if, wait, what? If we don't find u in the closed one, then we try to find you in the open. What do you do with the node? Bundle. So at that point we might if we don't find something, then you eventually have to create it. This one I'll just delete all the code. For now I'll just do like to do or whatever. We'll copy the code from up here afterward. It looks like there are two functions that will do the same thing, but it's slightly different. And I might be able to abstract it later. Okay, so this part here. Okay. same thing. I need to learn to use X. So instead of doing what I did, I can just use X. Okay, so now I look, has it already been explored and we're happy with whatever we explored? If no, and also let's just check. Yeah, there's nothing. Okay, so bundle enclosed, null. Costume, you're gonna come later. We'll do pretty much the same thing, but we're looking for an open here. Bundle in open. We'll rename this to just close. Bundle in open. Okay. I mean, the cost to n is just the distance. So I don't really care about it for now. Okay. So if we already explored, skip everything. Otherwise, it means that the node is currently in the open list, unexplored. So it means I found it from a different angle. If that's the case, then it's a matter of updating the node if my new path is better. Okay. But right away we don't care about the bundle itself. This only becomes relevant later. But I need the node. I guess I could extract it right away. That requires 2check, but who gives a shit? Bundle and open. I guess I create the thing. Okay. I'll just do it here. So if it's equal to null, I'll do node. What do you take? Oh, that's it. Horizontal, vertical. Fair enough. Else I'll extract it. Okay. I could just do it in line because I'm a bit lazy. And I feel it's easier to read. Is it null? Yes. Otherwise, no. This is easier to read for me at least. Wasn't there a different way of doing this? The new C# gives me something better, right? Was it bundle question mark? If I do question dot node, oops, or this, does it not work? What does that matter? Oh well, okay, fine. I'm getting fancy here. But I think this is the same thing as the line above. Because if this thing is null, then this whole thing is null. And then if this is null, then we go and we give you this. I kind of like this syntax. If I do that enough time, I'll just read this instantly. Okay, so now I got access to my node. Okay. What am I doing now? I forgot. I need some peppers. Okay. Give me 1 sec. I gotta help someone. Okay. Hey, by the way, for everyone that's new, I have a Discord server where it's not really active that much, but I'm usually there for chatting. Okay, what am I doing? I forgot. So now I get my node, and now I want to, from my current perspective, I want to find the magic. Right. Essentially, I need to do what I was doing here. By the way, you're useless. Useless too, pretty much. Okay. Let's look at the G. G, A. Let's just get you. Crop the content, sure. Okay, so what happens here? So my parent, bam, bam. So the parent has all the information right inside of this node bundle thing. This thing has like access to this data. Left, top, right, bottom. And that gets updated. Okay. Oops, wrong one. Yep. So that gets updated. Now I find this one. I invalidate the parent. In other words, this current node's center, I think center, now I have to make this a utility function. Where did I code my center stuff? This here? Yeah, let's add that to my utility. Where did I put it? Here. Public static vector center. Oops, not like that. Well, it could have been, but whatever. You're gonna take a rectangle R. You're gonna return this. Like that. so hard. I could have done that so much faster, but I couldn't think of the sequence. Okay, so you add these together, bam, divide. Hey, I wonder if I can save myself. No, I might as well not be that lazy. I could have put the divided by 2 here, right? And I could have deleted those. I mean, it's not the worst idea. But whatever, I'm too lazy. Okay. So now that I have access to that, let's use it. Utility dot center. I can't. I guess I need a center that takes both vertical and horizontal. Fine, fine. Public static vector center. Return vertical FH. There we go. Now we have access to that center. I might just call this get center to be more like, because that one is not a property, it's just that. I could be, but whatever. It has input variables. So I'll do this. Get center, I give you horizontal, vertical, and it should be okay. I guess in the end I didn't need that one. I guess I could delete it. It's not ever going to be useful, I think. Okay, I have access to this node. And this node has access to its center that I pre-compute here. Get center, I want to see that one last time. Yeah, that's good. Okay. Node. Is there a name for this pattern? Conditional operators into this? Let's ask someone. Do this public. You're gonna return a test, extract or create. That's what it's gonna be called. You're gonna take. You're gonna return an inner. I'll call this an outer. O. Return O. Dot inner or new inner. That's my pattern. to ask, like, is there a name? Is there a name for this extract we create? Okay, node. I guess I'm getting tired. It's already 11, but I don't really want to stop. I feel like I might even finish implementing this tonight. Yeah, I'm so close. So the first step is to know what is the first step? When you create a node bundle, there's a lot of things that happen here. You get access to a node, a parent, proxy cost, and your cost to end. Hey, how is the cost to end calc from this node to the end? I guess that's true. Yeah, but yeah. Yeah, the thing happens. This here. Set up nodes. Is there a way to do all the magic when I create the bundle and then I don't need to do anything? That would be really nice. Put all the code for the whole algorithm in very simple. So is this wrong then? Maybe it's wrong. Yeah, this code is broken. Okay, I have to put a note here. Fix me. The else branch doesn't mean supposed to use branches. We have to backtrack. This makes sense. I don't even know if I'll understand this. I guess I have to like fix that tonight. Otherwise I think I'll never understand this. This one I can get rid of. Start changing it. Okay. possible that a really far parent was the lowest. And then I might not be. I have an example of that, right? This one here. Oh, that's so funny. Where are my examples? I know I had some. Dang. Okay, not that one. This one? No, not that one. I saw it earlier. Which one was I looking at? K. K, yes. Okay, this one is a good example. Okay, bam, bam, bam. So here this parent is the lowest, or it's the one we keep. Now I break the parent. So now I backtrack, so I take this one, this is me. Then I backtrack to here, this is still me. This is still here. Then I backtrack to here, and that's how I find that. And then the parent is the old one, so I don't go further. Man, this is hard. Hard to write. Hard to figure out the implementation. Yeah, I think this there's a lot of steps we don't see in the way that we go from here to here. There's a lot of lost data here. So essentially we start from this green. So we make this be down here, then we backtrack to this green, which we're still down here, then we backtrack to this green, now we're down here, so we stay here. So if we backtrack more, we're back to the one that got invalidated. So this one we don't, we exit. In other words, a function that takes, so okay, first things first, detect when you invalidate the parent. I think that's what I'm supposed to find out. How do I know that? Okay, I guess I'm up here. Figure out if parent is invalidated. Update site that got invalidated. And you can only have one that's invalidated at a time because of the way that I'm moving one by one. Bam, 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 bam. Yeah, so you can only ever, since you're like moving along train tracks, pretty much, you're following the axis, it means that you can only invalidate one at a time. Everything else doesn't matter. Okay. Okay. So okay, I have access to this node in open. Now figure out get this node point of view, this parent chain. I guess that's how you should think about it. If this chain is better, update. Okay. Existing node. Parent is invalidated. Bam. Okay, I'll make a break here. Update site that got invalidated. Okay. What do you do after that? So it. So I go bam 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 bam. Everything's good. So maybe I add a function here. I could call it verify. Public bool verify. I give you a vector 2. And what do you do with this? You verify if you're at the left of the node, the top, the right, whatever, left, top, right, bottom. And if you are, do I return the enum of which side I broke? I think that's, I'm starting to understand. I think that's it. Could be validate. I'll call it validate. I like this word. Because just returning false, true or false, you kind of need the information about what happened. Side. There's no such thing as none. Left, top, right, bottom. Top left, top right, bottom left. I guess there is a none. If you're still inside, then it's okay. Very cool. Okay. Parent, very cool. Okay. So validate. So if you have a new parent, I guess this is the one. No, let's just not think about that. Okay. If that bound dot left. So what am I? If xy x is smaller or equal, you don't invalidate, right? If you're at the same. What if you're on it? It's impossible, right? You can't be on it because of the way everything's designed. You can't have a center. Well, you can if you're. Oh, that's annoying. If you have, let's say, something that is 1 in width, what is the center here? Oh no, it's okay because I use a floating point, so I do end up inside. Yeah, everything's okay. Okay. So if I'm below this, and I know because of the way I'm doing everything, only one can be broken at a time. So side dot left. Left is broken. Return none. Nothing's broken. So this is okay. X dot, let's do top smaller than top node dot bound dot top. Side dot top is broken. Else if xy dot y, no, x bigger than right node bound dot right, something like that. X y is bigger than bottom bound dot bottom. Alright, I guess I could do this. It's not needed, but whatever. Okay. So now we're able to validate and also get a side. That's really useful. Yeah, okay. I'm here. Figure out if parent is invalidated. So I do parent. Parent has to exist. Yep. Validate. What do I validate? My node dot center. I'm supposed to pick up the result, the validation. Var side. Okay, what do I do here? Update side that got invalidated. Okay. Also, I don't touch anything on the parent. This is all my own changes. Oh yeah, this is crazy. That's the world's hardest pathfinding algorithm or something. I'm sure when I'm done it will be elegant. Maybe. Okay, side. What do I do with side? What do I do with side? Okay, what did I do? Bam, bam, okay. So right here, invalidated. What do I get? I get the bottom. That's the result. In other words, I found this. So what I do is I do a bunch of if for which side I just broke. I could do a switch, but I hate switches. Side equals side dot bottom. I like it in other languages, but in C# I dislike them. I think they're better nowadays though. So I should end up with a vector 2. Call it corner. I do parent dot left. No, oh, okay, I started with bottom. Let's start with left. Left node dot oh, so now I found, let's say, the left. I invalidated the left corner. So I have to know if I'm above or below. If I'm above or below. Oh. So should this validate thing return the thing I'm about to find? It could be a good idea. What happened here? Oh, I broke everything. I guess it. Let's think about this. Maybe I can return more than just did that. Like return a side and a vector, or a side and something, a top or another side. The primary side and then the secondary side. It's interesting, because if you're left or right, you end up with the same thing. This was the one that was interesting. So if I invalidate the bottom, so I invalidated the bottom, and now I need to know if I'm at the right or left. If I invalidate the top, it's the same thing, left or right. Can I be like extra lazy? Can I group? Can I do something like side major, side minor? If it's none, it's none. Otherwise, can I do like major equals that? Okay, so this could be those are all major. Can I do that? Okay. Oh. This would be none. I'm allowed to do that, right? Nice. I'll just separate that because why not? Okay. Now we're looking for the minor. I really want it to be lazy. Essentially, I want to group left or right. Maybe not. Fine. If xy dot y is, let's say, above what though? The left node? I think. So here, let's say I'm at the bottom. Am I at the left of this bottom node or the right of this bottom node? Yeah, I think that works. If I'm at the top, then I can return side dot left, side dot top. This has to have one or the other. So I think it's valid to just not check the other side. think it's valid. Okay, so now if we invalidate the top, now it's X. This is wrong. If X is smaller, then it means we're above. If X is smaller, then top node dot bound dot left, come on, return side dot left. Should I use conditional here? It's so incredibly tempting. Let's try it. Let's see if it's readable. Return, and then I do xy dot y smaller than left node dot bound dot top. Dot bottom. Possibly better. Let's copy that. Bam. This becomes top x dot that. This becomes top node bound dot left. Returns left or right. Yeah, I think it's easier to read ever so slightly. Okay, right. This is the same thing. Nothing changes. Nice. Yeah, this is why I wanted to extract parts of it, but I couldn't figure out how. Bottom. Everything else stays the same. In other words, am I... Sure. So is my y smaller than the top? We're above. You know what? Never mind. Yeah, never mind. I almost saw something, but no. Okay, I got my validate, I got my major minor. So now that I have access to that, I have access to this side, which is now, I'll do major minor. Can I do that? Yes, I can. You have a type, right? Side, perfect. major, minor, major, minor. So now I have access to the actual corner, right? Bottom, left, bottom, right. If I see bottom right, then I know where to put then I end up with top right. Huh. Anyways, minor, major, minor. Let's do a bunch of if, major, side dot left, major, side dot left. The goal here is to find the vector. Should I just do them all together? No. Dot top. I don't think I need to. Corner equals parent dot left dot bound dot top. Is there no top left here? Oh, really? Huh. Should I just extract them myself then? No, whatever, we're not that lazy. Okay. Just do it here, new vector. There's a lot of room for cleaning up. So I get the left dot left, parent dot left dot bound dot top. This has, you have, okay. So the else is okay. Bottom, okay. That's the first one. So we did the first one. Else, if major equals dot top. Side dot left. Okay. Dot top node dot bound dot left dot node dot bound dot top. That bottom. Oops, no, stay top. This one is right. Else if major. This is repetitive. I guess it is repetitive. I forget what I copied. I'm assuming the inside perfect. So right Let's correct them. Right node. Let's just make sure left. Right. Okay. Top. And this becomes bottom. Bottom node. Oh, what am I doing? Okay, I'm getting tired, but I feel like I'm still lucid, ever so slightly. Okay, this big code chunk extracts the corner from whatever data I got. Okay, so now I have access to the corner. Okay, now so when I create the node, I guess node parent, I need a bool here. Bool. It would be nice if all this code ended up inside of this node. So in other words, here I would have almost real A star. Oh wait, I can do an optimization. Oh wait, oops, sorry. To do. Since we are in horizontal add, I almost forgot. We can optimize this setup, this search, moving alongside the horizontal axis. We can't possibly break up, down, top or bottom. Sure, I'll do this. Let's see that. Okay. Yeah. Okay, so this code will get simplified. This is why actually I separated horizontal and vertical. It's so that I could eventually optimize this. So remove all the code that's not required. Okay. I'm getting like some insight. Okay. I'll keep it because some of this code will end up getting split down here, I guess. Yeah, I guess that's what will happen. So validate, maybe I do a to do here. To do validate into horizontal vertical, something like that. Whatever. Where am I now? Okay, here. Okay. So I moved to a new node. I figured out if I invalidated the parent. If I wait. Yep, I invalidated the parent. I don't have to look further than the parent. Bam. I find this node. I find this, whatever this is, a corner, I guess. Bam. Okay. I invalidated the corner, or whatever the... Okay. So now there's like 4 things I need to update. Okay. I need to update... Oh, man. For each one, there's something different that happens, right? I really feel like this code belongs in Node. Do I do that right now? So what does it mean? I mean, what I had here, add if new. I check if I'm in open. I do a bunch of work. If it's not null. I had like this check. That minus that is bigger than that minus that. And travel cost is that. I'm sure, yeah. Then you have a new parent. In other words, what I do, so if I put all the code, whatever, all this logic in node bundle, so when you create the node, it does all this work. Then what I'll be doing here would be to create essentially a new node bundle from this. Then create a new node bundle, let it do its work, and then I compare them, which one is better. If the new one is better, then I update the parent. Otherwise, just do nothing. All this work gets thrown into the garbage. Thanks for a follow, cute developer 2021. Welcome. Okay, something. I feel like I get a small spark. Start like something. Okay. So what does it mean? It means that I'm in here. I try to find if there's an existing open node. Wait, that's wrong. Close. Oops. Hey, good thing no, I put the same thing. Open. Oh, that would have been a bad mistake. Well, not really, because I could have found it fast, but maybe not. Anyways, in open, check if it exists. Bam, bam. You get a node. So we don't need to reuse that. Or maybe we do. Does it matter? Not really. What's in here? there's nothing important here. Whatever. So we get the node, then we do node bundle new bundles equals new node bundle something. Then we do something if I'll do this. If new bundle is better, update something. I don't know what is here. Update old bundle. Else open add new bundle. What's wrong with that? Unreached, yeah, sure, whatever. Okay, that's clean. So this whole code will be that's it. In other words, the logic here will have to be done in Node here. I'll have to tell you what's going on. Are you like sliding horizontally or vertically? So when I do this, node parent, I won't be giving you this. But do I give you this? No, because I don't have this, so I can't figure this. Well, I can because it's from this to this. But we can compute it here. Okay, so step one, let's get rid of that. Cost to end. Now you're gonna be distance from node.center and all the way to, oh, I guess I need the end. Vector tail is called. Okay, this is no longer cost to end. Let's search for all the ends. You're gonna be cost to tail. That's my vocabulary. To tail. Ah, I cancelled. Tail. Perfect. No more tails. End. Okay. Now I know where I'm at. I'm inside horizontal. So I guess I add and proxy cost is no longer here. So something's gonna happen. Who knows what? I need to find that. Maybe. If the parent is invalidated. Okay. Except what do I do here? The first bundle, head bundle. I do need this, don't I? Huh. That's an issue. If I give you null, you don't have a parent? If you don't have a parent, first proxy. Oh, also, do I need this? really use for now, but is there a way? I kind of need it later, just not yet. Okay. So okay, so now I'm like breaking everything. So node bundle, you have a node, a parent, and now I don't have the proxy call that I'm passing anymore. I guess I pass you head to tail. Head node. Huh. If I pass something here, so I guess I pass vector 2 that I don't really know if it exists. XY, we'll call it XY. So it's either XY or node dot center. That's fun. Okay. So now you don't need this. There's still an issue though. What was I passing early in the old days? Proxy cost. Current proxy cost, which was always, so it was either the parent's proxy cost, and if something was not null, we were gonna create a new one based on, and then, okay, I see. Either it's a new one that I create, or it's directly the parent's one. Okay. In other words, if this is that's so bad. I need a way to pass the head to the first node so that oh man, okay, cost to head tail. Okay, so you're getting the tail, you're getting supposedly the head. Bam. Okay, now this is not null, therefore for the first one we're gonna use this, so we get the head distance to the tail. Okay. Alright. So I have no idea what's going on here though. Yet. So this is, what is this? Is that the best node? Nope, it's just the plain old one. Okay, with no skips. Okay. In other might be the parents or it might be mine based on the math that I'll do here. Okay. Am I all okay? So does this work? And then cost to tell, and then recompute cost. If I look here, oh, this is wrong. Wait a second. Well, I know it's not wrong, but why is it not wrong? Best proxy cost. All the way to the node center. Hey, I think I found a bug in my thing. Maybe that's why I didn't get the shortest path. Because I get the cost to the tail from like some either the center or the start. But if we have the start, the best cost is also going to be eventually the start. So you get the start to the node center. That's wrong. So yeah, you might be doing a detour. That's really bad. Huh. Oh man, I wish I didn't close my other thing from earlier. Dang. Might have been the reason why sometimes the other one was shorter. If it was adding a little bit of space. Yeah. Okay, well, how do we fix that? I don't even know. The cost to the tail. Simple travel costs. Oh man. If you don't have a parent, doesn't that mean you can skip this? And this? If you don't have a parent, isn't it just cost to tail? We're done? Skip everything else? Feels like it. But I don't want to add too much spaghetti or too much. Okay, let's think. I give you a node. I create a node bundle. I get a node, its parent, which will be null. If this is null, then this one will not be null. So we're not going to extract anything. We'll get the XY directly. That will give me the cost to tail. Recompute nodes. I feel like I should just do it. So if so we'll do simple travel cost equals 0. Full cost equal cost to tail. Did I forget anything? We'll do else here. It's probably not correct though. Simple cost to tail, I guess that's all. Alright. When do you recompute? When you get a new parent. Get best proxy cost. cost. This when I stop when you have, if the final node is the tail node. So that's kind of a problem. I might not get the shortest path either. If you overshoot the end to go to the center of this current bundle thing, so it's possible that we were overshooting on both sides, on the start and on the end. And I can't wait to play with it. Yeah, I think this means that we were overshooting. Okay, at least now we're not overshooting at the start. I'm gonna get a full cost. Oh, that's true. I forgot there was a fan. Okay. Press cost. Yeah, this thing here is just wrong. Almost wrong. It's right in all the cases except the last. Did I never think about that, or did I just not care back then? Okay, let's think about this. So you get the best proxy cost from my node center. Maybe I'm wrong. It's possible, yeah, I might be wrong then. Because the first node is from the start to the center of the node. That's your distance. When you go to the next node, then it will have its own travel cost from the best node. The best node might be the start, so this will be 0. Simple travel cost will be from the start to my center. Maybe I'm overthinking. Yeah. But I don't think I was wrong about the end. To tell. I'll just put it to do. S over that a word? Overestimate? Yeah, it is. Okay. Going from yes, yes to center to end to node center to end. There's no end anymore. This is still okay. Something like that. Hopefully that means something someday. I've been streaming 4 hours, rip. Unexpected. This is a lot of work. Okay. What is... Oh yeah, right, I forgot this is true, so it breaks. Okay, what am I looking at now? I want to move this code. So I want to be able to say node parent x, y, tail. Bool. Horizontal is horizontal slide. If you're sliding horizontally. Okay. Horizontal slide. Tempted to take a slight break. Maybe 1 minute, 2 minutes. I need to move the code here. Oh, now with this new way of doing things, since I'm gonna be creating a new bundle. Oh, so let's put a note, just like a line here. This means like everything below is not supposed to be here. Okay, so I created a new bundle, so things are gonna happen. And then instead of doing what I was doing like before, new parent, it will just be about stealing, like replacing a bunch of values. Everything that I compute essentially. So parent, proxy cost, that. So essentially this new parent will take all those values, I guess, and we're gonna replace them. To do this with values. Okay, I'll be right back.
robot.
Okay, I'm back. Sorry about the fan. We're back. Okay. So close. Okay. So I get this node parent. Okay. Node parent. That's all that matters, right? Setup nodes. What does that do? Right. Name the parent. I just want to read this. If so what happens if they're equal? If this is equal to this, we end up here, right? No, it does mean this is wrong. This is not true. I think. Or did I know something better? Why not? No, this is wrong. I mean, I had the reason, and I had the example though to prove me not. Wait a second. Which one? I forgot which one I'm supposed to look at. This one. Right. So setup nodes is wrong. Yeah, it is wrong. Because it's different if I invalidated the parent. It should be called if I did not invalidate the parent. If things are just working. Note this should be called if the parent didn't get invalidated. Hey, I guess I missed your follow. Diarrhea developer, welcome. Okay. No, this should only be called the parent didn't get invalidated. Okay. This should be true then. The case that was breaking that was when the parent got invalidated. Okay, so can I separate all the logic? First things first. Something happened. Invalidate something. Hey, thank you, Crabnet. Are you gone? If so, good night. Man, the thing that's so weird is that when I'm done with this, it's supposed to look exactly the same as this. Hey, good night. Like I'm not supposed to see any differences. But I'll know it's better. I guess that's all that's matter. Oh. This is so fun to play with. I wonder if I'll figure out a way to use this someday in the game. Oh yeah, I should try to fix that. It should not be like wiggling like that. The problem is that let's try to quickly figure out why. There's a place where I round to an int. Path editor. What do? You sometimes, let's say, add to path. It's already. Oh, I guess I just can't do that. Casting like that. Yeah. This could be a quick fix. I'll add it as a note. Yeah, this is bad, the way that it does that. Does it do that with everything? Because this one is rounded. Yeah, it's not a nice width when I'm snapped. Okay, let's just add a node. Path editor. This is the actual place where the code is. Add path. I guess I'll look for a rec. If I cast. Wait, I cast here too? Sure, I'll put a note everywhere. We do can't cast. No, I can't cast. The real reason is that need to round nearest int for all sides. Left. Yeah, the book can. Yep. Left top, right bottom. Okay. Come on. Why does it do that? What I have? Oh yeah, true. So now I do the same node for everywhere that I cast. There. There. Here. Okay. I'll just put it everywhere, because why not? Clean up this code. Nice, nice. Okay. That's it. Now they all have a node. Okay, I'll do a commit, I guess. And this will take 2 seconds to fix. I even already have the code, but I'm working on something else. Maybe I fix it at the end of the stream. Hey, Adepoken, how are you doing? Check this. I mean, you saw that I had that probably before, but I'm trying to get some nicer code. Some actual real space, free space pathfinding, or continuous space. I might start calling it like that, continuous space. Okay, check that. It's pretty fast. It's respectably fast. I mean, it's fast enough that I don't notice anything bad while I'm like even dragging. Like every time I'm dragging it, you're doing a new lookup. It's not like the terrain here is like that big though. There's not many nodes to search. Let's try it with a lot more nodes. Ooh, I lag. This is slow. Am I gonna crash? Come on, you can do it. I created 10,000 things and it's doing like a lot of work because know what? Wait a second. It's creating 10,000 things, and for everything, it's updating the pathfinding. Oops, I forgot about that. Yeah, oops. Apply selection. Where did I put the code? Create stuff. In here. Yeah. Okay, well this is gonna go on for a long time because it's doing like millions of things. Hey, welcome, Jitspo. Hey, how are you doing? Were you streaming? Hey, welcome to my humble stream. I'm doing some funny pathfinding stuff where so I got this algorithm that I first implemented in GIMP, essentially like through layers. And now that I feel like I understand what I'm doing. Hey, welcome everyone. Hey, big fan, Jitpo. Nice. Hey, welcome, an anonymous cheerer. Yeah, sorry, I got distracted. Yeah, so now that I understand, or I feel like I might understand, I'm trying to implement this. Unluckily for you though, I have, wait. This whole thing is not used yet, so I can actually comment it out. Okay, watch this thing. This is a beast. Pathfinding. Hey, have you been here before, Jitspo? Oh, what did I do? Yeah, true. Oh wait, no. I commented it. I uncommented before the time to compile. Oops. Okay. My bad. Okay, I guess I can give you my game pitch if you want to hear it. This is gonna compile. Shouldn't take too long. Ah, nice. So I'm working on a game where you're on an alien planet. And on this planet, all life has evolved to use volcanic energy. For example, the trees here have free-flowing lava going inside of them. And in different areas, you have explosion bursting out. So in this game, you're controlling a little creature, and you're trying to avoid getting exploded. So every level is a puzzle that has a cycle, and you're trying to memorize the pattern and not die. Right now though, I'm working on the pathfinding itself, so I created a sort of standalone map editor. Yeah, the fan is exactly in the microphone. Yeah, exactly, it's exactly pointed. I guess I could do better, fine. I don't know if it's better, wait. Yeah, okay. I think it's better. Yeah, exactly. Well, yeah, that was... my excuse was that I was gonna do a fan sound instead of music like I usually do. Anyways, yeah. Definitive improvement. It was sort of making me sleepy, the fan sound. And hey, thanks for the follow, Grey Artificer. Okay, check this magic. Let's hide that. So I can create like the terrain. And this is what I call a free space or continuous space pathfinding algorithm. So it means that you get the true shortest path. Not only fans, true. Hey, in the future it might be though. Because they're going legit or something. Yeah, so as you can see like this thing, you get the shortest path. any angle. But my current implementation, I did it in 2019 or maybe even 2017. I think, yeah. So yeah, I'm trying to update it and trying to think of a better way of thinking about it. So the way that I do it is actually um, not too hard to understand. The implementation is really complex, but understanding it is really easy. So what I do is I optimize my space in vertical strips. Hey, thanks for the follow, Bubble Fish. So I divide all the terrain in vertical strips and also horizontal strips. So both strips together create what you see in a what you call a node in A star. So by doing it like this, I get like optimized nodes. I don't have to have like, let's say you have a huge space. You see how this is huge, but in all of this I have only one node, so finding the path is instant, because I mean this is one node. Anyways, so yeah, this is the first part is space optimization, and then from there this is where like the algorithm is a bit complex. Let's see, J, I guess J is a good example. So I started doing this pretty much on paper, just in GIMP. So let's say you have this terrain, and then each of those here are the nodes. So I go from node to node. So let's say I'm in this node. Now, because I divide the space horizontally and vertically, I have the knowledge of how wide this whole area is. I wish I could make the selection a bit more obvious. I guess I can highlight. Pretty cool, okay. Yeah, so now I know how wide this is and also how high this is. So I go from node to node, bam bam, and I try to keep track of the leftmost point, the rightmost point of the areas that I'm visiting. So for example here, this is the bottom point, so I'm comparing, for example, between down here and here, but this one is higher, so I keep this one. So for this node here, I'm pointing to this place, while here, since this is the same height as this, then I can update this to point to the new node. And now let's say I go down. Now something interesting happens. You see how I ended up below the bottom? So by doing this, I'm able to find different features on this map. So here this would be a corner. So I skip a bit of details, but it's kind of visual, right? You can see how, like from this thing, I'm able to find this. With a bit more work, but yeah. So this is roughly what I'm doing. So as I'm moving, I'm discovering corners. Let's say I look at, maybe not that. I guess this one is fun. So check this. Let's say I start here, and then I'm moving around. Bam, bam, bam. Things are updating. Bam, bam. Found a corner. Bam. Found another corner. So you see how you went further left, further right than this. So I end up finding, bam, this. And then bam, you're exploring, found this. Nothing. Nothing. Right now this is not actual like pathfinding, this is just me moving around randomly and trying to see what I find. So we found this. Bam, find this. So it's all about how you leave different zones almost, and then you find stuff as you're going. Bam. And then after that, it's just a matter of if this point is above. So like essentially for every point, let's say you start, I guess this is a good example. Let's say you started here and then you found this corner, then you can draw an infinite line with a normal pointing in the direction of, if you're above the line, then you don't need to go through this waypoint or this corner. So you do the same for all the corners, and so essentially it's a sort of line of sight. Yeah, so as long as you see a point, you can go there directly. That's pretty much what the algorithm does. So implementing this is a bit hard, but the general intuition is not like, it seems obvious that it works, at least to me. Anyway, so that's what I'm trying to code. So like, yeah, if you have this, you see how like, yeah, this is the old implementation. Let's see, we put that up there. It's really fun to play with it. Bam. Let's hide that. Oh, that's so cool. Hey, peace. Yeah, good. Hope you had a good stream. Have a great rest. Yeah, same. It's kind of funny because I come to your stream often just to lurk. And yeah. You almost convinced me at some point to try Godot, but then I stick to monogame. Hey, thanks for the follow, cheese combos. Okay. Oh man, that's, yeah. There's something satisfying about seeing things updating like that in real time. It feels like almost a string algorithm. Okay. So right before you guys arrived, I actually came back from a break, so now I have to remember what I was working on. Yeah, right. Alright. Oh, sorry. I just hate hot peppers. Okay. So I'm trying to move some code, all the code below the line, somewhere else. Get this node's point of view from this parent chain. Figure out if parent is invalidated. Update side. Okay. So there's part of the code that doesn't look too bad. Oh wait, I didn't think about that, rip. I guess it doesn't matter. Okay, so we have a first node, parent, which is null, head xy, tail. I guess we just need to give you false, we don't care. Okay. I wonder what breaks my highlighting here. What if I do 1 equals 2 or sorry, I'm debugging my syntax. Sometimes VS Code has errors. Never mind. Okay. So everything, all the magic needs to happen here somehow. Okay, step 1. Check if you got invalidated. Okay, let's just copy the whole thing. Okay. This can be cleaned up, but for now it's okay. So what do you get? You get access to node, parent, this will be null, tail, and is horizontal true. Okay, we'll assume that everything got coded perfectly. If everything is coded perfectly, in the old check, oh, don't look at that. Parent full cost minus cost to end. Why do we have to do that? So wait, let's go check A star. Let's look at this one. When do you update a parent? So this node T has parent. Null. So while queued at parent, this is at the end, right? Return true. Yeah. Q, okay. Wait, is there a bug here? No, because you have continue. Okay, that's a case where you do update the parent. So what is Q? So you get access to Q. Q gets popped. Open this is a sequence thing, right? Not sequence, a priority queue. Sorry, I'm looking through this implementation by Randy. Just to get a reminder of an actual A star implementation. So pop min Q P Q where was P? Ah, the point, right? Okay. So if we reach the end and we want an output, that's funny. I didn't really think that would be desirable. So you can do the pathfinding, but not care about the result. I wonder if I should do that. Yeah, reverse. It's funny to see the coding conventions, how it's so different from C#. Alright, so if we're not at the end, Also, Q is my current. Wait, so there is a bug, I feel. So we add cute A star. Add successor. So you get an array that is size 8. You also have the next count, so you're incrementing. Okay. Okay, we're adding to the next. It's possible. Oh, right. Okay, so if it's already been visited, it means it's in the closed list, so we don't update it. But it's instantly set to visited. Wait, I feel like this is wrong. Where's the part where you update a parent? So if n has already been visited, that's a pointer. So you get access to the node, the actual node in the, let's say, the global memory. I wonder why it's implemented like this. Okay, so let's read this. So n p yeah, I feel like I'll have to message him. I think there's a bug here. Because you might end up finding a better path. Unless it's impossible because we're working on a grid. No, it is possible because let's say you have a big grid with a wall and your target. So you go towards the wall and then eventually you have to backtrack. So yeah, you might need to update the parent. But as soon as you visit something, you never hit the parent anymore. I'll tell him. We'll see, maybe I'm wrong, but maybe not. I like this. Doing 1D arrays. Self-casting. Self-cast. I forgot how this is defined. This is an input. Oh no, it isn't. Oh, it is input. Yeah. Yeah, as soon as it's visited. This gets pushed to the open list. So when you pop it, non-traversal. Thank you. I forgot now what I was looking for. A rip. Yeah, I'm getting tired. But I want to finish this. Okay, I have to think about it step by step. So I end up here. Find the node if it exists. Create a new bundle, something. Here I was looking for if I need to update. Right. In the old way, I was doing full cost minus cost to end. That's so weird. I'm comparing the two parents, trying to see if one is better than the other. But that's not good. I think I have to base. Yeah, okay, I think I got it. I think what I have to look bundle in open that full cost, if it's no, if bundle in open equals null, then we do this. Otherwise, else if bundle in open dot full cost, if it's bigger than my new bundle full cost, then we update. So we do bundle in open dot can I just call apply? No. Override new bundle. think I'll call it override. So we don't have access to new parent. This will be override. What do you get? You get new bundle. Just bundle. So we get access to bundle at parent. We don't recompute anything, right? It's just a copy of everything. The node, sure, I'll just copy everything. Bundle that node. It should be the same though. Yeah, it's the same. Parent proxy cost bundle that proxy cost. What is this? It's simple travel cost equals bundle simple travel cost. Cost to tail. We'll just copy everything. Full cost equals bundle full. Okay, and then left node. Top node equals bundle that top node. Right node. Right node. Bottom. There we go. Manually copy everything. So now I don't need to call anything else. Just override. Yeah. Okay. That does mean that I might be able to get rid of this other function. Okay. Should I do R equal or not? If they're equal, we don't care. So, since we don't care, just do less work. Oh no. No, exactly. This is already less work. Okay. Did I say no! What is this? Anyway, it hopefully won't be there in the new algorithm. What is... I'll have to, let's just screenshot that in case I forget. Oh man, this is scary. I'm scared of touching anything in case it I can't reproduce it. I'm trying to get everything, but whatever. Okay, let's save that. Okay. I'll screenshot both. Wow, randomly stumbling upon bugs like this, it's so odd. Huh. I can't tell at all what's going on. Anyway, I don't feel like debugging that. Oh, what? So there's something weird going on here. Wow. What? What? No, this is a good one. I finally got a use for this one. There you go. Okay, don't look at this. This is not good. Uh, Hopefully the new implementation has this won't be there. Okay. It's just like that. I think the thing that is really bad is this. Well, it's this along with um, this this function. It's just so bad. Having like a sort and then sign and then spot in list and oh man, it has to be because of this. And I guess in the old engine, it didn't. I couldn't find those bugs because I couldn't do this type of movement. I couldn't edit the terrain in a smooth way, the same way. Okay, so wait. What? The destination can. What? Okay, this is just really bad. Yeah. Okay, don't look at it. Don't look at it. This is okay. That's why I'm like redoing it. I figure like with an implementation this bad, there's bound to be bugs. Okay. I'm assuming I'll put a note here. To do if this is to check if this is if this is the right way to if I wait, check if this is the right update. No, if this is the right condition. It might not be because I used to do this big condition. Well, not that big, but I used to check like all these things. So why? This is so weird. Anyways, hopefully new one won't have the same bugs. Okay, so Pathfinder 2. So now the algorithm is finished. This is valid. Oops. If this is good, then we'll eventually find a solution. Okay. now, so right now I'm coding from the top and going down to the bottom. And the only missing piece is what this does, the node bundle. Okay. Okay, don't worry about the code, just worry about the algorithm. Okay, here's all the magic. Okay, is horizontal slide. So wait, you're telling me that, in other words, this is gonna be the same as this. The only thing that changes is the true here. In other words, I should do bool is horizontal slide, sure. Okay, you're gonna be renamed to if new. You're gone. Didn't I just rename it? Ah, whatever. Okay, add if new, and you're gonna be get horizontal node. Let's just make sure -1. Left top, left bottom. Aren't I getting up, down? Yeah, I'm getting the one at the top and the one at the bottom. I guess it's true, the ones at the top would be horizontal. In other words, I'm sliding vertically. This is false. Okay, I'll have to like change the word because this should be true here when we're here. Otherwise, this is really hard to read. Okay, true. What other words could I use instead of is horizontal slide? Because when you're getting, I guess I should just call it slide. Let's call it slide. It just becomes vertical slide. Okay. But then this gives you the horizontal nodes though. Top, bottom. Man, words, it's so hard. Man, on Discord I use the thumbs up thousands of times, and it still doesn't put that into my quick um, quick ones. Maybe I just keep it. Hit horizontal nodes, hit vertical nodes. It's hard to read, but hopefully I'll remember. Okay, whatever. Okay, so yeah, let's just say it's okay. This is okay. And now, when I create this, I just give you this horizontal slide. So that means I can just reuse the same thing. I mean, I could even, I guess, get rid of that. Maybe not. This is okay. It's kind of funny how we go through here, then we branch on both sides, and then merge back here. Okay. Note bundle. Let's go down here. Okay, now we're finally here. Okay. If I can code this, I'll have an algorithm that works. Well, yeah, I think so. Okay. Okay. Figure out if parent is invalidated. Okay, so all the things that are happening. Shoop. Okay, let's do this case first. Shoop. That's a horizontal slide. Shoop. Okay. This is a movement on the x-axis. So this case happens. So this is the code that is this. This thing does that. Shoop. Okay. But you only want to do that if you don't shoop like that. Shoop. Okay. If you do that, oh, there you go. Yeah, that's the case I was looking for earlier. Okay. Shoop. Okay. Shoop. Okay, so I might find a new corner here. Okay, so step 1. We need to validate. Get this node's point of view from this parent chain. Okay, we don't care about that. Okay, figure out if parent is invalidated. Bam. If major is none. Bam. Then nothing happened. We didn't find anything. So if major equals, what is it, side none, then we do the thing. Also recompute cost, we'll think about that later. Set up node, bum bum. Okay, that's the small easy path. Else oops, I went too far. Okay, something happens here. What am I doing here? I'm trying to... Okay, so if the side is none, this is everything's good. We do nothing, we don't care. Like this. Well, I mean, we update the size, but otherwise nothing weird happens. Okay. If it invalidates, bam. Now we have a bunch of stuff to do. We're trying to... Okay, I need a new function similar to setup nodes, but that one has to backtrack, and the exit condition is, so it backtracks recursively, and the exit condition is the parent. Well, no, not the parent. The parent's something. Okay. Hey, how are you guys liking the fan? Doesn't it add something? I don't get annoyed by fan sounds. At the last place I worked at, we had like this huge, what is it, air system. And I thought it created a mood. And then at some point in the evening it would shut down every time. I don't know what time it was, maybe 6 o'clock, 18. And then everyone were cheering every time that happened. And I was like, oh no, the fan. Okay. Am I really supposed to code everything? Oh, frick. Fine. Void. Setup. Left. Oh man. Here's the issue. When Thanks for following us, U squared. Welcome. Okay. Here something happens. I go towards the right, so I have to update the right one. But then there's also another thing that updates the stop. In other words, I still have to call all of the setup nodes except the one that's invalidated. Can I like validate? Validate gets called once. Can I invert the logic? So I call validate here, and then I do this if it's not, if major is not this. No, left, top, right, bottom. Setup nodes. Change of plans. I think I can push everything down. Okay, so we set up the node at the start. This ends up down here. This is okay. Why are you unhappy? It's possible to be null. True. So if I do like this, yeah, okay, fine. I guess I do a check if I'm allowed to do this, right? Side major, side minor, like that. Awesome. Oh, they've added so many options. Huh. To the Twitch interface. If sure, we'll do else major, oops, side dot none. Sure, oops, this should be minor. It means nothing, I just made up those words, whatever. Alright. Okay. If something like that. The issue is that I kind of need this information elsewhere. Anyways, this might just get disappeared. Anyway, whatever. Let's think. Major left side. No. If this is not left side, we do our thing. There's some probably an else recursive backtrack. Okay, if major top okay, bam, this, otherwise we do this, bam, recursive backtrack if it's not top. That makes sense, right? Okay. Major does not equal side dot right. Man, I don't know why I'm forgetting all my my skills. Okay. Here's what I should do. There we go. Side dot bottom. Okay. What is this? Oh, never mind. I thought that was a, a bad copy paste. Okay. Major equals does not equal left side. I'm assuming this is right. Okay. Else recursive backtrack. Dang. Oh, recursive backtrack. Okay. What do we do? We'll look at a bit further down because this is more interesting. Wasn't there something interesting happening? Didn't I have some enlightenment like a few minutes ago? Wait, what was it? Ah, it is there. This is literally there. Okay, this blue line. Okay. So I go down, I invalidate this, bam. Now we're backtracking. So we start here, bam, and we go back. Okay, okay, we start here. We memorize this point. We backtrack, bam, here. So we're still here. Memorize this, so it's okay. Bam. Now we're here. Memorize this point. Bam. Or is that where we're breaking out? Because this one has this. Wait, wait. What happened? Oh man, I'm so close. Okay. How does the backtrack work? How do I end up here? How far do I have to back? How do... So right now here, this is the last. Bam. Whoops, wrong way. Still last. But this one is here. No, this one is this. This is the actual. So do I break as soon so now I find this guy's actual. Keep going. This one's actual. Down, keep going. And now we end up here. And that's where we stop. So I think I had to go 1, 2, 3, 4, 5. And then this one we ignore. So of all of this was the last one. So do we know which parent to end on or not? I know which one it points to, right? I know. So if this is left, it means I invalidated left. Right? Yeah. I was to the left. Okay. In other words, I want to backtrack and I give you if it does not equal left, it might still be none. Wait, no. If it does not equal left, then we do this. If it does equal left. Did I get this wrong then? I should move. I should invert. No, this is okay. If it's not equal to left. In other words, if we end up here, it means we end up here. We have left. If we have left, it means we have a parent. It means we can backtrack. Okay. What's all the errors up here? Little... Right, that's a thing. Okay, we don't care though. Okay. So step 1. Private void backtrack left. It doesn't need to be recursive. I give you the Apple node exit condition. There's an exit condition here. Otherwise, well, maybe not. It's not recursive, so I don't care. I don't need to bootstrap. I can just do like whatever. Okay, backtrack, left, bam bam. Set up node. I mean, does it return something? It might. Left node equals backtrack left. Okay, let's assume that's okay. Hey Randy, how are you doing? But you're not uh, Randy, right? From the Qt framework. There's no way, right? You wouldn't have that name. Maybe? Ah, nice. Nah, nobody. Hey, but I'm glad you're here. Um, yeah, right now I'm so deep in code, it's crazy. It's oh man, things are yeah, I did. This is inspired. I'm trying to get something that's very close in terms of the feel. Yeah. Oh yeah. Are you doing a Boombound or a different game? Different. Oh, wait. Do you have a link then? Do you know Boombound by the way? It's a pretty good game. It's a similar concept but for mobile too. I can probably find it. Man, you write bound in Google, they don't like it. Oh wait, I wrote the wrong freaking word. Okay, no wonder. I guess it's on Steam. Though it's obviously made for mobile. That reminds me of Level Up Bound. All private. Oh well, are you in my Discord? Uh, Feel free to like add me. Then if you have stuff, I can check it out. Sorry, I wanted to rewind because I didn't see correctly. I feel like it's hard to do it on mobile. Are you in the Bound Discord? Where we play often. What about power? Oh wait, power ups and bounce. Wait. Oh what? Absorb damage. No, no. Oh yeah, there's a lot of people. We even have a clan, an active clan. Sorry, you gotta hut. Join my Discord. I'll hook you up. Whoa. Sorry. Yeah, well, welcome. You can be our newest recruit. Do you still play? I'm guessing you're Azrael, right? So many years. Yeah, well, get back to it. Site for records. Yeah. I checked what we got now. There's now a whole new website, bounding.net. It has every single map you could imagine. I made a bunch of bounds. What was your name? Oh, there you go. I see you're there now. What was your name in SC? Let's go check it out. We'll see if you had any quality stuff. Alright. I haven't played. Okay, let's see. So yeah, I'm working right now on pathfinding, trying to get something better. I'm making my own handcrafted engine. So wait. I remember making Iris Bound. Iris Bound. Oh, they don't have it. That. Maybe it wasn't written like that. Iris. And it's crazy how many maps there are. Line bound. I'm guessing those are all lines. Sorry, I'm trying to find it, but I couldn't. I guess they don't have that one. It sucks. I found some of my maps that I never backed up on that site. Yeah. I was in clan MP at some point. APOS. Or variations of that. Oh man, so cool. There's another one that's making a version. They called it Rat Cave. Wait, what was it called? Oh man, what was it? I should know that by heart. I think I have it on my itch. Oh, that's so good. Kick-ass. Oh yeah, I should mark the stream. I forgot. I haven't been streaming much. 8. We're in August 21. It's been 1 month since my live stream. Wow. Time flies. Okay. Let's see. Collection. Library. Oh, it's not there. Oh, Rat Race. There you go. I just started it. I could have also just looked at their page though. Oh yeah, I'm lagging. Ooh, I don't think I can play it on stream. Oh, alright, maybe it's fine now. Whoa. Oh, what? Right, I forgot. This freaking game. They have rotation too. Wait, that's actual StarCraft music. Today is oh no. Oh, it restarts. This freaking game. And they have good effects. Oh, this thing. Abomination. No, you're not allowed to do that. What is this? Okay. Oh, I did that on purpose. Oh, I did that again on purpose. Okay. Yeah. Wait, how did you find me? Oh, what? I was expecting something. I hate having to move my camera. Oh, I can zoom out. Nice, nice. The colors are hard to see. There's not a lot of contrast. Oh, nice. Well, never mind. That's runnable. Yeah, all the early things are oh, this is lagging. Whoa. Oh, what? Okay, I did not expect that. Anyway, yeah, pretty good. Mine is better. So mine is set up on an alien planet where all life has evolved to use the volcanic energy. So for example, the trees have free-flowing lava inside of them. Ah, nice, nice, yeah. Yeah, so the trees have free-flowing lava inside of them, and in different areas you have the lava bursting out. So yeah, this is a bound game. Here, I can give you the link. It's free on itch. Not mine, but theirs. I'd show you how far along is your game. So it's pretty good. Here, I'll run it. It will probably take a while. I should have done I should set up some pre-built. I say that every time and I never do it. Set up some builds. Hey, thanks for a follow. So you're doing it mobile. How do you do that? It feels like it would be hard. Because you have some like fat fingers trying to click on the screen. Is that how you do it? You click, or do you do the other types of movements, a bit like a joystick? For mine, I have no plans yet, so this is how it looks. This map sucks. The level design is not very good. I would. Yeah, the whole thing is bad. This is using my old engine. Oh, what? It's really late, so I that's my excuse. So I can have things like this, dead ends, and then I can have a different level here. Oh, what? Oh, I thought I had it. That was a... I don't usually solve it like that. Oh, God, okay. I don't know the patterns anymore. I designed this a long time ago, and I know that all the patterns suck anyway. Okay, fine. Man, I should do a hardware mouse, and then the mouse could go behind the plants. That would be funny. There we go. I can finally do it. So I designed the game as a sort of open world, so I can go back and replay stuff. So if I'm not in a level, the camera follows me. Movement is not very good, but I mean, the idea is there. Oh wow, got it. Oh, come on, misclick. Simple controls, left, right. Oh, okay. So you don't click on it. Okay, I see. No, I hired an artist. Yes. And then that's it. So the game is designed with a pathfinding, not a map editor rather. So I can go like on the side and start plopping islands. So the art was designed as a sort of Legos. So I take this, and then you can put things on top. Shadows are done automatically. Yeah. I searched for months for someone that could execute the exact vision I had. So this is yeah. You can see how you can go. Like things are done to look pretty good. Let's say you want this big part, and make sure. Normally you put a bit more room, more breathing room, but whatever. These are like parts are like a bit more unfinished for the map editor. So I can put a bit of this. Let's see, I'll put it bigger here. That. So this is my old map editor. Right now I'm working on my new stuff. So I'll put that there. And I will, yeah. Anyways, that for. And we'll put the grass up here. I'm using C# and working with Monogame. So Monogame is, I don't know if you know it, it's the spiritual successor to XNA. Yeah, C#. Yeah. Put all that. It's kind of cool. Yeah, it's been a while since I toyed in here. There's so many bugs. Well, not really, but it's not as smooth as it is in my new stuff. Yeah, so that's a nice little area. Then I can set up walkable areas, path. There we go. Let's say this. Oh man, it's so clunky compared to my new stuff. Okay, then I create a level here. This will be the start, the end. Oh no, it's just start. Right. We'll put the start here. And then right away I can come in here and then walk around. Looks pretty good for something I just put in a few minutes. Pretty cozy. Oh yeah, that's true, I forgot. It needs explosions, right? So then you can just do like patterns, like, I don't know. Oh, I didn't give myself much room, but whatever. 800. And this will be a loop time of, let's say, 1200. Yeah. Yeah. So my new setup is even better. I'll pause that. New setup is like this, where it's so much smoother. I can zoom in, zoom out. I have a grid. I can select stuff and move them. Okay, I'll need to, yeah, whatever. I can like resize stuff. This will not really be used for this game, but it could be later for other things. Did I have other things? Those are technically like different images. 6, 7. Godot. Ah. Yeah, I mean, it's a lot of little things, little bits, one a little bit at a time. I started working on this game in September 2016. Somewhat on and off, learning as I go. Hey Tatak, I'm redoing my pathfinding algorithm once again. This is the old one. Hey, you remember somewhat the big lines, right? How it worked? I figured out a way to do it better. Oh, by the way, this is really dynamic right now. Yeah, segmentation. So yeah, the segmentation is okay, but look at this. You remember like a long time ago, I mean, I did this video and things, and the implementation sucked. Well, I mean, it was okay. But I got new ideas. Check it out. It's a lot lazier, trying to do the least amount of work. Let's say you start up here. With this implementation, I never need to group the horizontal, the boundary. So this part, I never need to group it. So like as I'm moving through it, I only update the things that require updating. Everything else stays. Bam. So you see how this one is still pointing down here, because this was the highest bottom compared to these. Sorry, I'm not gonna explain it well, but whatever. So when you go down, now it's where something happens. So this blue that you went lower than allows you to find the corner. So like as you're going through this, you're able to find corners. So that's my new way of finding them. So when nothing interesting happens, nothing happens. Oop. I skipped a lot of details, but that's a general idea. Very elegant, but it's hard to implement. Hey, did you just wake up? Backtrack left. Okay, how do I code this? Here it's like 3 a.m. Started the. Wait, I've been streaming 6 hours. No. Well, at least I didn't put any music, so that's okay. Yeah, I'm doing a fan stream. It's more ambient. I don't actually dislike it compared to music. I wonder if I'm smarter without music. Who knows? Okay, how many lines is this? 400, not bad. I'm sure I'll figure out better implementations even later. Alright, so backtrack left. How do we code this? How does it work? Okay, so we start at my current node, and then we go to the parent and we compare. Okay, wait, what do we compare? Okay, let's backtrack a bit. So when I invalidate, I know that the, let's say the bottom here, what do I know about this? I know that there's nothing in the nodes that I visit. Bam, bam. This one is the highest bottom. In other words, there can't be anything higher than that one because it's the highest bottom. So when I start backtracking, 1, 2, I can stop. Yeah. Okay. Backtrack. This will there will be like a while something. While I don't know what, but something. I start at myself. If this is equal to this, I go here. Yeah. I start at myself. So Apple node left equals oh, it's just me node. That's the default. While something now. While left current what are you trying to fix? I found a bug. I found bugs. Probably I don't know if it's having headaches. Headaches are good. The main reason is I think this implementation is interesting, and it's possibly less annoying code. Because if you look at the code here, I have, for example, I have code like this, which is really annoying to look at. There are like 2 do's that I never took care of. If I go down here, you have like a bunch of recursive functions everywhere. I have like a thing like called get corner, which look at this. create an array of float corner. A corner, by the way, right, I forgot. A corner is a top, is something like that, whatever this is. Error is in here. None. Okay, I've created an array, horizontal lines, vertical lines. Shoop. I put values in there, and then I sort both. And then I do something with points, and I find the sign direction, find a spot and list. What is this? This is a loop that returns an I. So I'm counting something. Yeah, it's expensive. Like there's so many things. Like, and I think this thing is broken anyways, but whatever. Line X, direction X plus equal, yeah, whatever. So it's, oh man. And then corner orientation, and then we check if it were top right, and then we return the opposite, bottom left. Yeah. And then this line X is used as an index inside of these arrays from the start. Oh, that I sorted. We end up with this item 1, which is like the floats, corner orientation. So that, oh yeah, we go from here to like this. We return this something. Sometimes it returns null. the yeah, I don't know. I think I was smoking some good stuff when I coded this. I don't even know how it works. How does it figure out whatever it needs to figure out? So now that I did this, no ducks, yeah, exactly, no code. I mean, I can see that it almost works, except for like one bug that I found. This. You see, earlier I managed to do this. So I think my old engine was limited enough that I couldn't end up with cases like this. But my new one allows me to do like a lot more stuff. So yeah, I don't know, maybe it's when I ported the algorithm, maybe I made some typos. So I could probably like go line by line, try to compare. But I did that a few times and I couldn't see the differences. So maybe the algorithm is broken. This is weird. Who knows? In most cases it's fine, but I want all cases to be fine. Okay, how do we backtrack now? Backtrack left, current. Current is node. Or current is left. Is it more accurate to say that? Who knows? Okay, so if while current does not equal parent dot left node, is that it? Yes, we know it's not null because we're here. While that, and I guess I return left. Or I return current. We don't care about left. Maybe. Okay, that was funny. Yeah. Oh man. Okay, current does not equal Hey, check it out. I changed the background to space. It feels better to to be in here. I did a sort of photo bash of a bunch of space images. Now it just feels like it's huge. And then I made a bunch of gradients. So yeah, that's how I even have like different types of, they all look the same, but yeah, it's different gradients slightly. Anyways, now it looks like a pro, except for the UI, but it's crazy how you change a bunch of little images and now things look better. You see, like, this thing is slow. Or maybe it's not slow. I don't lose any frames and all that. Yeah, I mean, for purposes, for my game, I don't even think I'm gonna be modifying the terrain at runtime. So I guess it's okay. Anyways, backtrack left. What am I doing? I'm going through something while I have to go all the way back. I start here. This is me. This is the node here. I go to your parent. I look at the node. Oh, it is correct because I went to the parent left node. Okay, that's good. Oops, wrong one. Okay, so this would not be my parent, it would be up here. So we keep going, and I need to memorize. Oh, this is wrong. I see what I needed, left. Let's call it best left. We're gonna return the best left. Current. If current dot bound dot left. If we're backtracking left right now, so if the current is more to the left. Oops. The left is this. Hey, good night. Or morning. Okay, left. Okay, maybe I don't start with left, I start with bottom, since bottom is what I have in my examples. I can just make one. Fine. What goes after K? I forgot. L. Alright. We're gonna start here. Oops. Bam. L1. We'll do the path right now. L2. You're going down. Sure. L3. And L4. Okay, we'll stop here. Start with red, bam. Okay, blue. Okay, we're red. Okay, we end up with this. And this. Blue. We didn't change the blue. Okay. Red. Still up here. Still on here. Blue. Up here. Down here. Okay. Bam. Now we broke left. Where do we end up? Still. Okay. Now we have this top, this bottom. Pretty cool. Okay. So what happened? I got my own left. I backtracked. And I kept the smallest, the most right left. That's what I did, right? I kept the most right. I guess like if instead of there I went down here and then here, this one would have been better than this one, I think. Most right left. So if the current left is bigger than the best left dot bound dot left, then we are happy. That's it. And we escape when we find parents' best left. Best left has a value no matter what. Okay. So we're fine. I guess that's it. We're just looping. Bam bam bam. No need for recursion. I wonder if I should do the same thing here. Just use a while loop instead of this. I was really into recursion a while ago, but this is not hard to read either. Top. This would be the same. Desktop equal node. If they're equal, I keep mine. I keep the first one I find. So Apple node current equal node. I want to use best left, desktop, whatever. Oh, I don't have something that works though. This doesn't exit. So current equals that parent. Oh, I don't have access to it. Huh. Okay, well that doesn't work. In other words, this is wrong. This is a node bundle current. This. I start at my node, so I did this dot parent then. Now I can end up with null. It's not equal null. Guess I'll do that. I got bootstrapped. Alright, so that's good maybe. Just copy that and rename stuff. Desktop. Okay. Okay, I guess that's okay. And I did say if you're further right, then you become the new desktop. Okay. I'm bound to eventually have this be true, right? Or this equal this. I assume that is true. Okay. Let's use the other one. Right. Yes. Right. Okay. If it doesn't equal the right node, smaller than the right. That's right, everything else. I might optimize this later or like refactor, but for now it's okay. This bottom. Perfect. So I think I got this working. Okay, so the top node equals backtrack top. So it's not really a recursive. Firebase. I heard about it. I haven't used it. By the way, welcome, Chintuk. Right node. What do you want to know? Probably close to 15 years, dang. Bottom node. Bottom. There we go. Cancel because of the stupid. Oh, rip. Absurd. Quick start. Crashes on several devices. Oh. Wolverine. Ooh. 2 versions on this side. Oh, that looks nice. Wolverine. Oh wow. That looks good, the image. 2009. Ooh, you got Angel Fart on there. Killer, nice. Killer is still around, by the way. Yeah, a bunch of Kick Me, that guy is pretty fun. Oh, out of water. Yeah, sorry. I'm getting tired, I guess. Hey, thanks for a follow, Chintu. Oh, that's a scary looking bug. Firebase causing crashes. Maybe that's that one will be hard to get help, because a crash like this I don't think is useful. Relevant code. Yeah, this is not useful for a bug report. Firebase. You should look at what the. Wait, where are we? Yeah, this is a hard one. Because with this, there's not enough info, I don't think. After installing from Play Store. There's only 34 errors, right? Quick start. Oh no, that's some good memes. Oh, that's some good stuff. Oh, that's funny. That's a bot. So, like, one of your user gave you that? Yeah. What does this thing show? Quick start Android. Did you have a version that worked in the past and then you updated and you ended up with this crash? Or did it never work? It's working on your device. Crash analytics. Because here there's not enough info. Like there's a bunch of things, but it's not really what. If you can, try to do a minimal reproduction. So like a project, pretty much hello world, that does nothing. And see if you can get the same crash. Oh, it was from the start. So I'm guessing you don't have the right setup then. Is this updated? This is 17 days ago. It's still maintained, it seems. And no one else has that bug. What I would do is I would look for maybe a YouTube tutorial instead of this. Oh, I guess it's from them. Yeah, I guess it's better. Oh, Firebase is Google, huh? I didn't realize that was from them. But it's working on your device. Yeah, so what I'm guessing is there's something wrong with the configuration somewhere. Okay, let's reread again then. I guess I'm starting to understand. Connection. The issue is with SQLite. Cloudflare. First. I'm guessing there's an issue in your initialization. Maybe you provide something wrong, or the database is not done correctly somehow. Yeah, that's true though. So some people it works and some it doesn't. Because I was thinking maybe it's a like your own error, but maybe you're right. But you'd think a big project like Firebase would not have bugs. At least no real configuration bugs. Set up no reason. Alright, where was I at? So now that I do this, I think I have everything that I need. If you can, you have to simplify. Try to remove every line of code that is not related. put some breakpoints if you can. See which part of your code triggers that. 33% of people. Yeah, I guess it sucks if you don't have a device though to test it with. So I guess what you can do is try to do logs. Try to like put in your code base. Try to pinpoint what's going on. The control flow of your app. Or try to find the common factor in all those devices. Manual logging, yeah. If the errors are happening in your users' devices, then you have to extract data from them. So set up a lot more logging to see if it can help you. Okay. Okay. Major, minor. Is that what I have to send back? Then I'm able to find a corner, maybe. And how do you find the corner? Oops. So I broke the left bum, and that gives me left bottom. Left bottom gives me left is the major, bottom is the minor. In other words, I end up with this sort of line. Bam. Bam. So the major so if I have a bottom left, it's just minus plus. Huh. Well, no, it doesn't work. I just realized. Oh yeah, it does work. Okay. Wait, no, it doesn't. So I'm trying to generate a point, preferably under the line. So a point anywhere. Here would be invalid. Invalid, invalid, invalid. Here would be valid. I have access to the information that this point is at the bottom left. I thought I had the solution earlier, but I just realized, let's say you have... Oh no, I did have this. No, I didn't. Yeah, I did have the solution. There's no corner. Yeah. So the range for this line, it's this. Another word. As long as I'm here. Let's see. How do the servers work? It's a BattleNet. So you're able right now. Well, since like a few years, you have StarCraft is now free to play. So you can get an account for free, and then download the game for free, and then connect to the servers for free. We play usually on US West. And then if you log in, you'll see that there's still a lot of people playing. You can pretty much get in a game at any time of the day. There's no lag, I don't notice it. You get lag if people live far away. StarCraft is a peer-to-peer game. So you use the server to find people to play with, but then after that you have a direct connection. So your lag is based on how far you are to other people, not really to the server. So as long as I generate a point on the right side but below, bottom, left. So I generate a point to the right of the line and below the line. So I end up like in this quadrant. I think that's valid. You can't. Yeah. The line can be like very like this. So this line would still give me this. Or like this. This line would give me this. Or if it's like really sketch and the point is here, I still end up with this. Yeah, that looks good. Okay, that's what I found earlier. Alright. In other words, it's based on the major. So you have to be. So you respect the minor, but you go inside the major. I think that's what I'm supposed to do. Corner, and then I do C. This is gonna be C, point C. Sorry, I'm looking at the feature request for an app I use. I saw a pretty good one. Okay. So I think I do end up with my var major minor, and this has to be returned. Okay. Side. No, time flies. Okay, let's see. What's wrong with the C? Okay. I mean, this one is also never used though. What's wrong with this one? Maybe null, but it can't really be null. Oh. Also, I should be using the other. Okay. This one would be not null. They're never null. Alright. So if we're major left, let's start with the one that I saw, left bottom. Then we can do, I mean, I can just take arbitrary C, we don't care. So left bottom is this. We do C equals new vector 2, where what do I do? I have the corner. Oops. So all that I need is minus plus. No, plus plus. Yeah. So I get, let's say, corner plus, I mean, the numbers don't matter. I'm too lazy to do F. Maybe. Okay, if it's instead the other one, so it would be plus minus. Okay. Now, my major is the top. Oh, come on. I have so many things open. Okay, major is the top. Let's say this one. If I'm on the left side, okay, let's just duplicate this and then try to do scenarios. So we find this corner, we get this, let's say this line, we're coming at it from somewhere here. In other words, we have to go here. So that's, let's say this is the right side. Let's start with the left side. So that would be minus plus. Minus plus. Right side. Plus plus. Oh, very interesting. Keep going. Major is right. Let's restart. In other words, we wrote this side. Bam. And now we're coming at it from here. So as long as we're here, we're fine. So we end up with minus plus. If we're on bottom, if we're at the top, okay, so if we're at the major is right, top, minus plus, minus minus. Okay. What about the other one? Minus plus. I wonder if I can do it better after. Okay, now we get bottom is the major. I don't know if this map has a, I guess here. Okay. So I end up here, end up here. So we end up with minus minus. And then plus minus. Does that make sense? Are they all unique? No. Well, okay, fine. Okay, plus minus. Plus minus. It's the same. So bottom left. Bottom left. Wait, Let's look at minus minus. Bottom left, right top. Huh. So do they all have, okay, so plus minus. Plus minus. So bottom right, left top. Bottom right. Huh. So it's like a rotation. Okay, so plus plus, plus plus. It looks like there's always only two. Minus plus, minus plus. Plus plus, minus minus. Done. So I think this looks correct. Minus plus, minus plus. Minus, yeah, plus minus. I think that's good. So I get from this C and a corner. In other words, I found my new proxy cost. So if you don't find a proxy cost, what happens? It's just the parent's proxy cost. You don't do anything. In other words, it's this case. Proxy cost equals parent at proxy cost. Let's do that. But it's possible that I don't have a parent. If I don't have a parent, then I gotta create the proxy cost. Oh no. Proxy cost equals let's say new proxy cost, where I give you my corner. I mean, it's possible that I end up with nothing, right? No. I think this covers all the cases. And we'll just try to crash it. Again, let's just go edit this. I guess I don't need corner at all then. Because, yeah, you just end up finding it. In other words, I know right away my restriction. So what does it mean? It means that I should just take that in the constructor, and that's still gonna, oops, I went too far. Proxy parent, and then restriction, like that. It might be still null, but it doesn't matter. Now we don't need to set that. Restriction is with the best parent. Bounds. Bound. I forget if there's an S or no S. There might not be any one though at this time. It auto logs in for me at this point. Best parent, set restriction, best parents, XY. So what does it mean? When I create it, do I have access to the best parent already? Best parent is this. mildly annoying. I only get it later, like here in the constructor. Maybe this doesn't belong here. Does it belong up there in the... maybe it does. I think it belongs now in node. Man, there's so much code now that belongs there. Quite annoying. Did I really put corner C here? Oh yeah, right, I got rid of it. The alternative is to have two constructors. Two parent, I'll take it. Best parent, proxy cost. Best parent. XY parent. Okay, step 1. Oh man. Okay, I don't want to lose this coder just yet. So set restriction is gonna be gone. So this thing will not do anything except hold some data. Oh, I lost. This is in node. Okay, perfect. So now no one cares about it unless there's more. No. Okay. So this gets stashed right in here. Oh man, there's so much stuff. Okay, here. This is no longer public static. This will just be private, I think. Set restriction. I mean, this code will not exist anymore. So for now, let's just take this. Put it here. Something. Okay. Okay. This one. Okay, so let's go back here. Let's try to fix this. You don't need this. You don't have a best parent. And you don't have a restriction. You don't have this. You have now a best parent. Oh. Okay, maybe it was okay that the static function was over there. Maybe. Okay, let's bring it back. Okay. Public static. Okay. This is progress. Restriction. The restriction. The best parent. X, Y. C. I mean, I guess this one doesn't have a restriction because it's the end node. Yeah, there's node restriction. So get best proxy will be from how did it work? XY parent. Tell. It's not the greatest, but it works. It's okay, maybe. Null. Okay. I think that's valid. Yeah. So the goal here is to hopefully have something that works soon. And then, okay, what's your parent? Oh, also I get, I'll do this. I give you corner. Parent is what? It's my parent's parent. No, my. Is it this parent at proxy cost? I think it is, right? Custom. I give you best proxy restriction. Which is based on the best proxy at XY, and then XY is my corner, C is C. Why are they unhappy? True. Okay. Why do they care about C but not corner? They all work together. Okay, well, whatever. That's why normally this is okay. I think. Okay, get best proxy. PC. PC is what? Parent. What is the parent? It's the. Okay, there we go. Now the bugs. Am I supposed to just say equals null right here? That works. And I think if we're here, it can't be null. Also, we can't not have a parent. How do I know? I mean, if we don't have a parent, if it's null, it's gonna be none. So we'll be here. Oh, what? But it's possible for this to return now. Okay. I don't know. I think this is valid. If we crash, we crash. Yes, I don't need that now. So now there's no bugs. Well, no there's no red underlines. So I don't know, did I finish? I don't even know what I'm doing anymore. Oh, true. Anyway, for now we don't care. So what happened here? So I got the best proxy that I use for the restriction. Corner that value, see that value. Okay, let's see if we crash. Or if like anything happens. And all references. Oh, it's used so many. Yeah, whatever. So what is this? Pathfinder. You are now, well, Pathfinder 2. Awesome. Okay, moment of truth. I don't even know if I did anything. If we'll see. I don't know if I just like finished writing that and I thought I was done, but I'm not. Or okay, well, let's just see what calls this. So node this. I feel like this was okay because I coded from the bottom up. So did I just finish the bottom and now we're done? Who knows? Okay, so first things first is when nothing happens. Oh, we crashed. Okay. Well, I knew that. Never mind. Yeah, that was the last little thing to think about. It's possible that this is none. If it is, yeah, we'll do this. If parent. Actually, can't I do that? So now, if this is null, we get null. Wait, why is there a... Isn't that okay? Oh, okay, it's not nullable. Okay, I see. Yeah. So now we get that. Otherwise, we create a new proxy cost. What is it? It's gonna be at XY. No parent, right? That's parent. It's because someone got banned this week, and then he started to create a lot of accounts. And then instead of using, because we blocked the at everyone, so he started to put like hundreds of people in the like at specific people, and he just did that so everyone would get pinged. So if you don't have the phone, you can message an admin and ask them to give you a role. Once you have a role, you can bypass the verification. You don't have a best parent, and you don't have a restriction. Oh, but in that case, we do have that. If you don't have a parent, you do have the other one. Come on. Oh, that value. Okay, fine. That's the only case. So now, proxy cost. This one is not used anymore, right? Head, null. I think that's good. So this is gone. First cost to tell, it's gone. Let's just read that, because now we pass the tail here, whatever. And we do end up with this. So this is gone. Okay, surely I don't crash now. We'll see. Nothing makes sense. I coded this in like 7 hours. Why? I don't know. Did I code the whole time? I forgot. I played some games, right? Okay, moment of truth. Simplest case. Okay, well, this is promising. The line, there's a line. Okay. No. Whoa, this is incredibly promising. Oh, come on. I'm sure it's not that bad. It's probably just a silly mistake somewhere, a typo. Probably took the wrong corner. Yeah, I must have done... Yeah, I'm taking the wrong corner. Instead of this one, I take the the right side. Okay, let's have some fun though. Because I'm not gonna have this bug for a while. Well, for hopefully never. So might as well play with it a bit. Whoa, that's so fun. Oh. Dang, I wish I could use this for something. Looks so cool. Okay, anyways. One last. Let's do a loop. Sure, we'll do this. I just ate everything. Okay. Oh, a loop, look at that. Wow. I wonder if that could be useful. Oh, that's horrible. So did I invert everything? I think this thing didn't discriminate. Okay, anyways. So step 1, do this. Okay. Yeah, everything is in reverse somehow. How did I do that? How could I be... Okay. And then do this. Is it in reverse? Let's start with this case. Oh man, I didn't do any setup for debugging. Oh well. I'll have to mentally debug. So we go from there to there, nothing happens. We go down, bam. Okay, what am I looking at? So I broke major is bottom, minor is left. No, right. Okay, major is bottom. Oh, never mind. This is taking the right corner, but not of the right node. It's taking the right corner, not of here, not of like this part, but of this. So it's working as intended. Huh. Oh, wait, also how many lines is this? 400? What was it before? 429? It's longer, rip. But I think my code is, there's a lot of the same stuff. Okay, the bottom right. Major is bottom. Wait, I forgot what I'm looking for. It's here, right? Major is bottom right. So when I do this corner, so it's right, but I guess the parent is not the parent. Oh. I think my code works, but I'm taking the wrong variables. Bottom node. The bottom is correct. I find the right y-axis. But why do I find this one up there? Oh man, I don't want to debug. Why does right end up all the way right? Bound. This is a bound, a node. When I draw this, I do draw it, right? I don't draw it. I never draw this. Maybe this is wrong. So I guess I debug. Fine. Path editor. I could. Well, the thing is, I guess I should draw the one I'm in. I'll draw like the border thing. So I have like this selected, right? Current horizontal. This writes the circle. Let's draw also sb.draw fill. Oh, I don't have the latest version. Latest version is 1.4. 1.4. Let's do a quick .NET restore. Windows. Bam, I should get errors. Perfect. This becomes draw line. Draw circle. Draw circle. Okay. sb.draw rectangle. And now I do what? I guess I steal this. This is done. Yeah, let's just do var and the horizontal is the current horizontal, vertical is the current vertical. Okay, I'll do something else. Whatever. New vector 2. This takes what? X vector, vector, color. Okay. Oh, I kind of want to do a border. Okay, so current horizontal, drag that left, current vertical, drag that top, current horizontal, that drag that width, vertical, that drag that height. Okay, color dot, I don't know, yellow. That was yellow, right? Yeah. And let's say 4. That will tell me right away if something is going on. At least in my expectation. Hey, at least I didn't get any crash. That's pretty good. Oh, there we go. That's a mistake. Well, is it? It's so cool though. It might not be a mistake. It's probably working as intended. Oh, also I found a bug. This is preventing the garbage collector from touching this when I recompute the paths. Oh well, whatever. I noticed it because let's say I'm here and I do this. Ha, there we go, we crash. Yeah. Wait, what? Oh no, I just deleted the line. I thought I was wondering again. Okay, what am I looking at? So yeah, I can see now that my code doesn't work at all, not even close. The reason is that this is not the right things. I was looking for the right, not of the bound, but of the node. So can I go, is there a way? If I look at path, it's really annoying, really cumbersome. Bound, I guess I'll pre-compute the things that I need here. I'll do a rect. Public, rectangle, rect, that will be convenient. Rect. Rectangle, what are your values? So I take this one. I want, so you have this, they're this wide, and this height. So there's my horizontal, vertical. I take the X of the vertical, the left, I take the top of the horizontal, top, width is the width of the vertical, and then horizontal, I'm assuming, yep. Okay, now I have access to rect. Perfect. I mean, this is valuable too, so let's just draw both. You're gonna be current. Oh, I don't have access to that. But it's just a matter of inverting, right? Huh, very funny. So this becomes current vertical. I should have not done that. Current horizontal. Okay, I think I got it. Instead of yellow, I'll give you something. I could give transparency, maybe. I'll do red. Ooh, there we go. Maybe the red should be smaller. Maybe at 2. So now I found a new thing I should add to my library. A border, like a border to the border. That would be useful. There we go. Now they don't overlap as much. Maybe? Hard to say. Kind of sucks. Yeah, whatever. Those colors are not good. I'll make them black. Maybe double that. Could be black with transparency. Maybe. Yeah, that would look better. Alright. So now that I figured that out, let's go fix the bugs. Not here. So here, instead of bound, I need to replace it with rect. Alright, is that the only thing that I need to do? I think this is... No, this is okay. What about this? Also okay? No, I put a... This doesn't work, what I just did. Huh. Because right now I got access to... Yeah, I think I don't have it. Huh. Oh, I mean, let's just see what it does, but I don't think it works. It might be funnier though. Now it's gonna go like anywhere. Yeah. In some cases it will work better than what I had just now. It will look less weird, I think. Ooh. I mean, that's promising. It's not a lot to work. There we go. Why? What? Oh, okay, I'm typing the wrong stuff. Oh, because this is not connected. Okay, there we go. Fine, you win. Okay, I need to break this. This has no right to work. Come on. How does it... What? Did I just understand what I was doing? Yeah, that's a bug I'll have to fix. Okay, wait a second. Why does it work? It's not allowed to work. No. Wait, it should have found something at least, no? Oh, because they're not connected. No, they are. What? Oh, they're not connected down here. Yeah, I really need to fix that. It's a floating point thing. It's because I'm casting floats to ints. I'm not allowed to cast. Ooh, there we go. Found a bug. There we go. Finally. There we go. Yay. I mean, it works really well. Now it's just about using the values correctly. I think the algorithm structure is okay. Give me 1 sec. Okay. Hey, thanks for a follow, Nick, the kicker. Yep, I'm game dev. Oh, that's a heck of a shortcut. Ooh. Self-taught mostly. How about you? Wait, that was so funny. Why did it switch to that corner? Oh, right, true. Ooh, very good. That's a good shortcut. Oh yeah, online is the best way. Or rather, it's the only way. Even if you go to school, you'll still have to learn online. Disgusting. So should I just take the time to debug? Anyway, I don't think Hey, welcome, Alodis. How did you get first interviews? For ways to make my job easier. Help desk. Oh, hospital. Learn Python. Yeah, Python is pretty good for first language. Um, Other good language would be like JavaScript, C Sharp, not bad. So you're asking how to get interviews for a job? It mostly depends what you apply for though. C++. Yeah, it's not bad. Hey, welcome, Logical XX. If you stick to like nice code, like for example, this here is a nice C++. These types of framework, Qt framework, there's a lot of discipline in this C++. If you look at any of them. Oh, okay, automate. Yeah, Python is a good idea then. AABB3. You see, like this C++ is very, very clean. They use a minimal subset. Hey, thanks for the follow, Woodsby. So you met devs with no degrees. Yeah, there's a lot of devs with no degrees. Though I think the majority do have, I don't want to look at it now, but there's a survey by Stack Overflow. They do that every year, and I think, if I remember correctly, construction, nice. Wow, I've been here 8 hours, dang. It's 4 a.m., almost 5 a.m. Rip. Sounds harsh. Yeah, construction engineering. It's probably pretty nice though. It depends if you're able to learn by yourself. Some people, they need to, they work like nice in a class where you can talk to other people. Online you can talk to people too, but you have to be, you have to be more like by yourself, like you have to be more driven. I guess that's cool too though, like if you're more driven than everyone else, you do more stuff. The way that you want to learn programming is you have to learn vocabulary, like words. It's a lot of like, because learning, like computer science is all in your head, so you have to learn to visualize. It's like you're creating a word. Sorry, I can't even talk anymore. 8 hours later, you have to learn to. I forgot what I was talking about. I'm at 23 now, starting to study information. It's like you, at the start, it's like a whole field that's made of made up stuff. So to learn computer science, you have to learn the made up stuff. And at the start, you know nothing. And by itself, there's no like discovery. So essentially, you need to build vocabulary. You need to like learn to navigate this space. And the more words you learn, then the more vocabulary you have to search for more new stuff. So essentially what you're gonna write in search engines. So yeah, programming is like a huge made up field of imaginary stuff. So the more imaginary stuff you learn, the better you get. And yeah, that requires building words. And we use a lot of words that look like real English words, but they're all made up. Sometimes you're lucky and their meaning is similar to English, but sometimes you have English words that don't mean the same thing. Yeah, exactly. That will definitely help if you learn the lingo. But it's a lot of like, it's a bit like you learn by doing. You do simple stuff. Let's say you want to code your own tic-tac-toe game. You start like with some very simple stuff, and then if you're able to understand what you need to do your job, to do the tic-tac-toe, then you can start building knowledge. Some concepts, design patterns. Yeah, design patterns. I don't know if I would recommend that right away. Yeah. Learn maybe. I mean, okay, there's a few things. There's the thing that I just said about like learning words, and there's also the part where it's about solving problems. And yeah, that's trial and error. Like you learn to be smarter. So one thing, okay, fine, I'll go into my. I don't know if I'll finish my code today. I got a good start though. Here's one thing you want to learn to do. I'll pick this place right here. Okay. You want to take a sheet of paper and start solving problems. Let's say you want to put, this is my classical example. How hard is my pathfinding algo? Really hard. I didn't manage to finish it in 8 hours. So you want to learn to do organigrams. So here is like your first programming language. You have circles. Sorry, I can't even draw anymore. You have diamonds. What else? You have boxes. I'll show you what they mean afterwards. I'm a bit rusty. Is that all? UML? I wouldn't call it UML, just organigrams. Okay, so circles are for your start and end. Diamonds are for your decisions. The boxes, the rectangles, are for your actions. So here's a simple program that opens a door. So you do, this is your start. Senior dev, I guess so. Let's say you want to open a door. How do you do it? The door is in front of you, let's say. I guess that was a rhetorical reach out arm, sure. But at first you might not be like in reach of the door. So one thing you can do is do an action. For example, walk forward. We'll assume that you're facing the door. Yeah, exactly. Now maybe you're gonna check say here reach door. Did you reach the door? Exactly. Everything is just data. So here you have, did you reach the door? We'll start with the no. No. So on the no branch, you come back and you walk forward. Let's say you did. Yes. Then you can use extremes. I sometimes do. If you did reach the door, then just open it. We'll assume that you know how. Open door. And then we'll do exit. So if you start to learn to think like this, start like this. So essentially this language, you can do whatever you want. You can go really deep, like what does it mean to walk? So you could do a whole side program about like moving your hips or moving your legs or whatever. So you can go really deep, low level, or you can go really high level. Open door. Well, never mind. I was about to write like wall, but I don't care. So now we'll do like open door end. This is called an organigram. There must be something on Wikipedia about this. A flow chart, I guess it is. I just saw one. When I go in Google and I write algorithm organigram wiki, I get the things with the right shapes too. A tutorial for beginners. This sort of looks like what I just showed. I guess I got them all. Yeah, the circle. Oh, input, I forgot about that. True, you could do inputs. Process decision. So what is this? Creating flowcharts. Anyway, I'm sure you'll find more stuff. Recursion. This one, I guess, I mean, recursion. This one is just basic loops. It's not really recursion. Anyway, you have to start like thinking like that. How you break problems down. What breaks the problem? Like here, if I'm not facing the door, my program won't work. Here, if the door is already open, I can't really open it again. So what does it mean if it's already open? Do I just close it? let's say like you're somewhere so far away from the door, there's a stair. Maybe you need a process to handle that. So you have to like think a bit like that. What type of what breaks my assumptions? A lot of programming is that. Clean code. I don't know if one can learn clean code. Alright. Interviewing. You need some self-confidence. You need to be interested in the jobs you apply at. If you're someone passionate, it's a lot easier. Why did my other thing not work? How did I mess it up this hard? Hey, welcome, Ready Lane. How are you doing? Hey, how is everyone doing actually? Are you guys like sleepy? Almost sleeping? Or are you guys waking up? Oh, it's 5 a.m. I should go sleep. That's probably my longest stream in years. I kind of don't want to sleep right away though. Hey, no problem, Nick. So, what is going on? Let's just undo everything that I did. Go back to bound. Okay. Oh, nice. I'm doing a real space pathfinding algorithm. Right now, I had a first implementation that works in almost every case. Or continuous space pathfinding. C++ can be done for anything. C++ is what we call a general programming language, or sometimes a multi-paradigm programming language. Python also is a language you can do everything. I mean, a lot of language are good for everything. Oh, never mind, I'm just dumb. Even Ruby, true. What am I looking at? Okay. Wait, never mind. This proves... Yeah, exactly. It's a lot about preferences. Open your eyes. Yeah, it's a bit like asking a painter about their brushes. Because Python looks a bit like pseudocode. Also, it has a huge ecosystem, so a lot of what we call libraries of code already written for you. So all it needs is for you to learn how to use that code. Ah, I shouldn't have quit. Rip. Okay, restart. C++, no, I wouldn't say hardest. What's hard is just, I mean, I can't really say it's hard. What's hard is that it has a lot of language, I guess. So, depending on the code base that you're gonna be reading, then things can be complex. Okay, interesting. So maybe I messed up. Very interesting. Okay, everything looks equally bad. Okay, it looks like it's predictably bad. Because of the libraries. Yeah. I know there's Julia, I think that's becoming more popular now. Well, I don't want to look at it, but it's about like a lot of the time the community and the ecosystem. Essentially, let's say that people in machine learning decide to use Python, then they write a bunch of their own AIs, and then maybe they have forums and then chats, and then so essentially when you go in there, then it's a good idea to go with everyone else. Though maybe there are advantages to using Python. Yeah, community is OP. That's why, like, for example, C# is such a great language. For like any question you could have, you'll have someone to help. And also for almost, well, yeah, sure, fine. Yeah, Reddit, sure. Yeah, I forgot what I was gonna say, but it's generally what you want. Especially if you're a beginner, you want the solid language. Solid community, rather. Yeah, harder is a big word. So, wait, what am I doing? Okay, let's just go. I don't want to write, I'm too tired to write debugging tools. So now I'm debugging with my brain. That's a big, that's a smart. What day are we anyway? Are we Saturday now? Oh man. I've been streaming for 8 hours. Rip. Any book? Um. Hmm. So if I have this, the one I break is left. So I end up with left major, top minor. Okay, we're here. Bam. So why do I end up with this one down there? Left top. What? Sorry, I missed some comments. ADHD? Yeah, sure. There's a bunch. Let me check what the base course books. Maybe one thing I could recommend is look at YouTube. Start with YouTube. Do like follow along. And then as you're doing that, you're gonna learn words. Maybe you're not gonna learn. Whoops, sorry. I've been playing with like batteries. Anyways, maybe you won't learn the best programming techniques, but you'll learn words, and that's important. And then look at another channel that teaches around the same stuff, beginner stuff. Look at like maybe 5 different channels, and then you're gonna start to become inculturated. You're gonna start to learn, I guess. Even when you're yeah, it's all about that. You want to learn the culture, learn the memes. How do I end up down here? I guess this is not where I end. I guess I messed up. Yeah, oops. Okay, well that explains everything. Apparently my function is wrong. I'm guessing this one is wrong. Yeah. Yeah, just learn their words. Watch a bunch of YouTube channels. Not just Python, watch a bunch of languages. Well, no, never mind. Ignore that. Choose like your language, Python, and watch a bunch of Python stuff. Made any progress? Yes. I'm pretty much done. Kappa. You want to see the here? Grady. Hey, by the way, are you a game dev? Grady. Dreddy? Sorry. Check it out. So what do? You said I guess you didn't say, right? Okay, so here's what I'm gonna have at the end. It's a continuous space pathfinding algorithm. I mean, I should implement map saving so I could load a map instantly. Oh well. Let's hide that. So you see how you always get the shortest path. Let's add a bunch. Oop. Oh, right, okay. Oh. And it's IT sec. Okay. Nice. That sounds really hard. I've done a bit of it, but It's so fun to just see that happen. Shoot. The way it splits in two. It's a great illusion right there. A star variant, yeah, it's my own. I had like an. I guess it's outdated now, but the ideas are still true. You can check this video if you want. So it's a bit like something that goes on top of a star. But I wanted to have the shortest path, the true shortest path rather. Ooh, that's so fancy. Oh, you see, I don't have the true shortest path. What did I just say, a bug? You see, it shouldn't be changing anything when I do this. Anyway, that's why I'm re-implementing it. I made a bug somewhere. If you're still going to the same corner, it shouldn't be changing the path like that. Anyway, I think I know because I'm overestimating. Game is like golf, no. I can show you an old demo. Yeah, a cost function issue. I think it is. I know exactly where it is, if that's the case. I'm trying to test the new Windows file, but it kind of sucks. It's so slow. How do you deal with burnout? You don't. You try to not be burnt out. Try to notice. Yeah, maybe you're right, Zeus. By the way, welcome. So this is an old demo. So it's a game where... here, one sec. It's a game where you're on an alien planet, and all life on this planet has evolved to use the energy from a massive volcano. So for example, inside the trees you have free-flowing lava, and in different areas you have the lava bursting out. So in this game you control a little creature running on top of the trees, and the levels are like... Hey, thanks. The levels are patterns. So they loop, and you try to memorize the pattern and learn the safe spots. So this is what it looks like. This is an old demo. The art is a lot better nowadays. So if you're there, you die. Music is done by composer in Seattle. If you look at my... Oh, here, if you join my Discord, I put some of the stuff in announcements. Okay, so if you're there, when the explosion spawns, you die. Otherwise, you're allowed to jump into it. So a level like this is faster, but you have safe spots. If you're really good, you don't even need the safe spots. Oh, whoops. Oh. My brain is like slow. So yeah, so you can have skills in this. Some levels have no permanent safe spots. So in this one you have to dodge this line and then jump into the explosion afterwards. You can have levels like this where you have to backtrack. So you can think of this game as a maze through time. Hey, thanks. So it's a bit of a rhythm puzzle game. Randomly, no, this is all handcrafted. Osu, it's a bit like Osu, that's true. So normally in this game you'd be sitting here looking at the pattern, trying to see, okay, where could I possibly be? Obviously those levels are not for beginners, this is just a demo map for me to showcase features in the game. Indiedev, yes. Bum, bum, bum. So a lot of the levels can be beaten in a few seconds, but it requires skills. So a better first map would try to train you to be better at the game, not pushing you down a cliff like this. Ooh. I can't believe I used to struggle on that one. The obstacles will have better animations and sound effects, but they won't sync with the music, but the music is very rhythmic. This is my old big boss level. There's a lot of code that is open source, oops. But the game engine itself in full is not open source. Oh, whoops, so slow. Oh. Yeah, this was my big hard one. That was close. Oh, come on. Okay. Oh no, I forgot. Oh man, I never die like this. I guess I'm really tired. Bum, 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 bum. Dang. Did I try to cheat? No. Some levels have more than one path. There we go. Yeah, so here's an example puzzle level where it looks like you have a hole in the center. Boom. So you think maybe you're fast enough, you could make it. Go. But you're ever so slightly too slow. Even if you have the good timing. So this shows a bit more like the puzzle element, where you have to backtrack all the way. I'll enable the line here. Oops. Almost misclicked. Oh, whoops. There's a faster path, but oh, whoops. Okay, fine, I'll do it. And that's it. So a very simple game, but there's an infinite amount of ways it can be done. Okay, so somehow somehow my checks are wrong. Yeah, I think the reason why it's wrong is because of this function. You see how it's hard coded, so it gets like the best node. You can think of it as like um, let's say like this is the shape, and you start here and you go all the way here. For this point to like here, the best node from the blue's point of view would be here, that corner. So you get a distance essentially from the best node to the node center. So in this case it would be here, the node center. So you get the distance from this corner all the way here. And then you take the best node, travel cost, essentially the distance from the green here all the way to the corner, plus the distance from here all the way to the yellow, plus the cost to the end. So the yellow towards blue, and you see how this would overestimate. So I think if I would fix that, for example, if the end is inside of this node, don't go to the node center, I think that's what would fix the cost. But I don't care. I don't want to fix it. How? Which one am I breaking? Okay, validate. Hey, do we want to take bets? What? Why does it like this corner so much? Okay. I get right. Oh. I kind of knew that. Wait a second. Wait a second. If I get it right, top. Wait, never mind. What? We don't end up here? We do. But we end up down there. So the minor is bottom. Why? Did I really invert every single minor? Don't look too close at the variable names. Yeah. Well, would it work? Distance squared. Then I wouldn't get the true distance, right? But I guess it's okay if everything is the squared. I'll have to think more about it. Is that usually how it's done in the A star? If I look at this one, oh, not this one, A star, not this one. Heuristic. Isn't that the square root? Yeah, but for A star, for like distance, I think we need the real distance. Otherwise, you end up somewhere else. But maybe it's okay if I use for every, because I use distance here, here, and down here. Oh, do I use recompute cost anymore? Only there. So I guess it's used only once. So I guess you get it once per node. Anyway, why do I end up with bottom? That's so weird. Let's look at this again. I get right. X is smaller. Oh. I guess they're right. Yeah, X is smaller than the top here. Huh. So the one that I'm using is wrong. So for all of this side here, I'm not looking at the correct variables. So I don't want to look at bound for this. I guess it's okay for this one. Yeah. Yeah, I think you're right. If I use the distance squared everywhere, then it's... Yeah. I'll have to try it. There's a... Well, for now I'm not thinking of optimization. I'm just thinking of the structure. Just to see... I want to get an algorithm that works, and then I'll... There's a lot of room for improvements after that. Yeah. There's like a lot of code that I can refactor or clean up. That's something I never really did with my last implementation. And then it became crusty. I was about to sneeze, but I guess I don't need to anymore. Um, So I guess for the major, yeah, I forgot to use that. I was too lazy tonight. Okay, wait, let me check. So bound. Okay, so for the left, what do we do? Uh, if I break the bounds on the left, I have to look at the left node, but not bound here. Top, but top of what? Rect? No, maybe. I mean, rect is fine. Top. That works. Okay. That's the same. I think I can just do that for the thing that I call a minor. Is that it? Mistakes were made. Mistakes were made. Okay, I got a lot of mistakes here. Typos. But let's just try it anyways. That might work now for some cases. Nope. Still broken. Possibly because of the typos. But let's just see, right? The minor is wet, bottom still, huh? Okay, but let's just fix typos. Okay. The left should be left. The top should be top. The right should be right. Bottom. Did I really leave that like that? I don't understand anything. The algorithm looks like it's doing what it should be doing, except for like some variables that I put at the wrong place. Alright, what was I doing? This. Ooh, not bad. I mean, I'm using the wrong one, but it's now this one. Okay, let's see. So we're supposed to end up at top. Bound at top, true. So for the minor, I used the same thing. Yeah. Well, the thing is that this is deterministic, even though it's hard to understand. So, minor, top. When top is minor, we do rect. When bottom is minor, we do rect. Minor is left. Minor is right. Minor is top. I don't understand anything. Minor is left. Bam, bam. Is that it? Now I should be pulling further from the right. I mean, it started to be like a bad choice to do it like that, but I guess it's okay. Like instead of using rect, I should be probably using either the horizontal or vertical, one of them. Anyways, let's see. It might just work. Ooh, it works. Let's move that down. Ooh, it works. Let's try this side. Oh, I forgot to invert them. Whatever. Let's just go back. start there, and there, and there, start there. This, and then this. Wow. Okay, can we break it now? Let's try a bunch of stuff. Let's try this one. Cool. So I still suffer from that that cost thing, but whatever. When I see the lines of code that that I don't need to see anymore, I'll be able to put right into the trash can. Whoa, it works. My IQ is way too high. I can't believe it worked. I mean, it's not even that bad of an implementation. Like, I have at least 400 IQ points. Yep. I can't believe it works. The I don't know if I'll find mistakes here, but so far it's like exactly how it should behave. I used to have sorry, I'm eating hot peppers right now. I used to have what a lot of test cases. I should do a query a bit bigger. That way, like, if I put it outside, it could snap to the closest side. So that it doesn't disappear like that. I guess I commit this first implementation. Whoa, what is that? Why is there so many things? Okay. Let's just commit first a few things. Utility. Yeah. I don't know. I just tested and we didn't see anything wrong, so I guess it's all quite correct. Path editor, pathfinder, what is this? Oh, I don't think I'm committing this. I think I'm undoing, even though it's good changes. This pathfinder thing is going down the trash can. And it's not like I want to pollute this local Git repo, right? And it will just make the other one look so much better in comparison. If it's not that, undo this. Okay, let's do update apple.shapes. Bam. Get center. Is it used here? No, right? It's quite dangerous because I'm about to click undo, but what happens if I undo on the wrong file? I'm gonna lose all of tonight's work. I guess I like to live on the edge because I'm about to do it anyways. Oh shit, no, okay. Sorry, let's go. Pathfinder 2. New Pathfinder implementation. Worst thing, I would have had to rewatch my stream and try to copy the lines, right? Let's just do let's be a nice programmer and look at the code. Okay, this looks good. Looks good. Okay. Yeah, sure. Approve. What is this? Corner? Oh, true. This is why we do merge reviews. I almost missed that. I mean, this whole thing is not required anymore. This one, yeah, there's a lot of room for optimization. Look at this. Find node in list for each of the, and then I have this custom equals that takes, oh man, okay. Yeah. We'll look at this someday. Maybe not. The freaking, yeah, there's a lot of looping here. Get best node, look at that. I'm looping through my list, open list. Find the lowest full cost. And that's how you pick. So essentially every single time I go to the next node, I loop through the whole node list. For every node, loop through the whole node list. And not only there, but the other place too, whatever. This find node in list. So I get my best node, bam. Then we go down, choop. Yeah, sure, fair enough. And then we loop through the whole closed list. And then the whole open list. Yeah, there's a lot of optimization. Okay, what was I about to do? Delete corner. That's such a huge improvement, not having corner. Well, not really, but whatever. So this, do I push this at the same time? I guess I do. Okay, let's keep going. This is all good. Oh, okay, it's a split line. Okay, I see. Yeah, this looks okay. Well, is it? Yeah, this is okay. I mean, it's not the nicest thing to read, but whatever. Perfect proxy code, yeah, perfect variable names. Alright, single iteration. This can be deleted, but I think I'll keep it for now. I can just put it here, because why not? There's no point making a single iteration inside of this single iteration. Anyways. This is good for the future computer science historians. It pulls the amount of chat messages from the server, and if it changes, it's fetching the whole chat history. Nice. Yeah. To do user. That's good. Okay. This thing. I'd really like to figure out another way of doing this, but I don't know of any. Whatever. So add if new. Why do I not use link queue? Okay, I'll use link queue, at least. Well, maybe it's more obvious to optimize without link queue. This can just be done with a link queue. Bundles. I mean, okay, let's just write the link queue thing. So you go close, you do find. What happens if you don't find it? It's not really find, it's first. What if you don't find it? Can I see more dots or something? Okay. Okay, there we go. Wow. What? Whoa. Is that a bug? Who knows? So what am I supposed to do here? I kind of want to delete. Did I break? So having this there breaks my thing. It's like the code doesn't want me to do any work. So check horizontal, check vertical, sure. So I'll just give you a whatever. A where a dot what? I don't have access to it. Node. I did go through node. Yeah, okay. Horizontal. Do I do it this way? And vertical equals. I'll just replace that line with that. It's literally the same meaning. Oops. Normally it's not broken. Let's just go remove the other equals. I don't know if I should keep it, not really. What did I break? Nothing, perfect. Okay, what do we have now? Do I still have something that doesn't look like it's broken? Ooh, good enough. I'm assuming it's not broken if this works. We'll do a to-do though. To-do. What would be the right way of doing this? Yeah. Should I just use a dictionary? Who knows? I'll put the same note here. Don't optimize. Is there a lot of to-do here? 7. True. Oh yeah, this will be a huge one. This saves a lot of time when I can do that. Separate. true. Oh, I guess I put a note. Nice, nice. It's a priority queue. Fair enough. Okay. Okay, where were we? I mean, I could get rid of rect. Even though it's used, I could just get rid of it. Wait, did I really use that? Wait, never mind. Where are we? Upper rect. Oh, because it highlights all reg, but it's not the same. Okay, true. Anyway, the few times that I used this one, I could just not use it. It's not like it costs anything though, except a bit of memory. Okay, let's keep going. Get hash code, yeah, whatever, standard. Okay, I mean this is okay. This is okay. Sure. I'm sure I can figure out a more elegant way of doing this someday. Oh, what is this? Okay. It's crazy. This function is so magical. This whole thing is what powers my Pathfinder. But it looks like it does nothing. Default to 0, that's good. But in every single case except the first, it's not gonna be 0. Wow. I really like this restriction thing. I guess now we don't care about this one. I could get rid of it. It's not hard to re-add someday if I need it, but I don't think I'll ever need it. And it saves me a few lines. I'm on a line budget. Okay, I guess I'm committing that. It's not even real commits. Yeah. There we go. $1,000,000 code base right here. What is this? It failed my code review. Not bad. I mean, my other one was somehow less lines. No, 430, 447. But this one I have a lot more confidence now. I'll have to test a lot of things, but this thing is so much simpler. It's crazy. Okay, you wanna have some bleeding eyes? Get corner position. Essential. Wait. I think this was, you give it like pretty much a rectangle, and an XY, and it's trying to find the closest corner. I'm assuming this is what it does. And look at this. Freaking arrays. Left, right, left, right. Is building some hashing. Yeah, exactly. That's why I wrote like a dictionary thing here somewhere. I wrote dictionary, but I meant hashing. For direct accessing. I'm guessing you mean for close and open. Uh, a big thing for like similar to what you just said. Maybe not. I guess this is already like a ABB3, so a query like this is not too bad. Then I do this for like this. So this is like the broad search, and this here's the narrow search. It's the real contains. Huh. Yeah, this is okay. It's not like the worst. It does mean we have a bunch of queries, but this is pretty performant already. AABB. Get this node. Oh yeah, that would be a huge improvement. Yeah, anyway, I don't really care. Okay, let's try to do a million, or let's spawn 10,000 nodes. Let's see if how it behaves with a slight stress test. I'll go somewhere here. I just need to make sure those dots are not on the screen, or I'm gonna lose a lot of performance. Okay, spawn. I guess I'm still. Oh, it's not bad. Okay, so now I spawned a lot of stuff. Let's put this guy here and this guy here. Okay, now let's try to make a path. Oh, I'm losing so much performance. It shouldn't be this slow though. Fine, okay, you'll be in the corner here, but I'll put you here, just so that you don't do so much lookups. We'll try to do this. Okay, this, and then here we'll link this here. We'll go down here. We'll go up here, up here. Yeah, true. That's why I put it outside. But I feel it, after I'll optimize, it will not slow that much, I think. Is that one? Where are we now? Oh, we're so far. Okay, I'm gonna cheat. We're gonna go all the way. I'm like, okay, and we're gonna go all the way here, let's say. We still want some detail. It's my game will never have this big of a map. You go here. That looks all good. You can go here. Okay, I mean, this path kind of sucks, maybe, because it's kind of direct. Anyways. I guess I'm just being nice. You'll go here. And then here. I wish I could have changed the color of the one that I'm touching. Alright, you're here, now there's a path. Ready? Let's make the start be like some... Let's make it big so that I can be zoomed out. Like that. Okay, well that's slow. I wonder how many millions of nodes it's going through right now. I wish I could see it like expand. I should do some debug. Code the Pathfinder as a coroutine or something. Oh, true. Yeah, because every frame we're looking through the closed list and the open. Oh, true. Yeah, no, yeah, I'm killing it. I'd like to see how much bandwidth. Yeah, and it will probably the garbage collector is going to have some fun here. Well, not really, because is there a garbage? Yeah, I guess the link queue does garbage. There's a bit of garbage with this and this node bundle. Here there's garbage, but probably doesn't matter. I wonder if it will ever find a solution. I can't wait to see the path. Oh, man. Now, implementing the pathfinding was pretty straightforward. Yeah, there was a list operation here, first or default. That's probably not very nice. It's looping through the list, yeah. Add. I'm surprised this works this well. But I guess that's standard. I could do before I end the stream, just switch to a dictionary here. This might instantly speed it up. Yeah. But those lists are kept, so I mean, at some point they should stabilize. Stabilize. It's really not done. Hey, welcome, PhD Horrible. It's a custom continuous space pathfinding algorithm. I'm trying to stress test it. Right here I have millions of nodes. Are we gonna get something? I wonder if like this is something that will take hours, or if it's about to be done. Oh, you know what I could do? I could do a pause. But how would I know where we're at? I guess I can pause. Let's pause. Ooh, we're here. Ooh. Oh, okay, yeah, we're gonna be here forever. This. Let's see, how many? Hello. Yeah, well, it could be better. Close that account. How is that a keyword? Oh, because I'm in the lambda. Can I like put a breakpoint here? Ooh, okay, not bad. 19,801 explored nodes. What about close? Open. How much things are pending? Oh, not bad. 252. Let's put a breakpoint here. Oh, that's pretty much instant. Or maybe not. I guess those loops are very fast. 90,000, that's nothing, right? Wait, wait. Let's go back up here. Ooh, it's fast. I mean, each iteration is fast. 11, 13, 14. You're getting swapped. Dang. Okay. And sometimes new ones are found. So 19,800. 20,000. It's not as fast as I thought. 20,551. 20,900. Yeah, this is not fast. Well, I mean, obviously, but okay. Let's just see the horizontal dot count. Ooh, 13. Vertical dot count. 14. So that times that. I think that would be acceptable. No, there might be even more than that, but let's do it. 13 times 14. 51. 196 million. But I don't think this is accurate. Because if I look at this, here I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I can't math, so 535. Is that accurate? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, there's a lot less. There's 15. Okay, so there's not like 100 millions or something. Am I paused right now? I am. I should not have paused. I wish I knew where we were at. Can I go here? Okay, we started at there. We want to go there. Where are we right now? Center. Are we almost there? Maybe I shouldn't pause. Yeah, probably. Yeah. Hierarchy, a hierarchical pathfinding algorithm. Yeah. Well, I did a lot of I guess not on this scale, maybe. Yeah, this one has so many branches to explore that yeah, there's a lot of stuff. It's really I really want to see the POW though. 100k node strategies. I'd really like to compare implementation someday with some. I want to write a research paper on this. I feel like there is no one that did what I did here. We got a path! Whoa! Okay, now do not touch anything. Luck. Okay. I mean, that's kind of scary. I think it makes it has to be. It's very close from the shortest path if it's not the shortest path. But I think it's the only, yeah, like it over evaluates a little bit the end, but everything else should be pretty spot on. Well, it's 6 a.m. in the morning, right? Yeah, do not touch anything. If I touch even a single rectangle, it's gonna recompute the path. Wow. Well, I mean, it's kind of obvious that it has to be the shortest path because it's not linked perfectly everywhere, right? Oh, look at this. That's so interesting. So like for this area, it found this path that it thinks is shorter. I think it looks shorter indeed, right? Or not? Is it? Or is it not shorter? No, it is shorter because this is almost a straight line with a bit of... Huh. Yeah. Anything else that's surprising here? You see, this is so nice. You see, like this straight line? Shoop. So I don't see anywhere that I'm going over space. So that's a really good sign. I wish there were, I did it differently though, because I made a path that's really close from being always going like from bottom right to top left. I should have done a few parts that were going backwards, because right now I'm testing almost only the same thing. Yeah, I don't see anything obviously wrong here. I wonder how many minutes it took. Yeah, I'm slowing down a bit my rendering. Yeah. There's a lot of room for optimization in this engine, but I don't think I'll do it because my game is so simple that I don't need it. Okay, reset. Let's redo a little bit, but another last test, but a smaller scale. I should probably end the stream though. Alright. If I do it closer. Okay, now let's just take this. Oh, it's so slow. Yeah, I'm doing a bunch of things that are not good in terms of performance. I should not compute my path optimization. I think. Well, maybe I should. Anyway, yeah, I don't care. Alright, so is this small enough? Oh, this is slow. Hey, welcome Elvis. Hey, peace. Yeah. Why is it so slow though? They're right next to each other. Maybe my algorithm is really bad. Maybe I'm not picking the best nodes. I'll have to mark like which nodes are in my open or closed list, because this is way too slow for this short area. It's gotta be exploring a lot further. I mean, it's almost a straight line. Once I put my thing here. Like, I can explore it faster manually. Anyways, thanks for watching, everyone. Join my Discord if you're not there. Otherwise, I'm kind of happy about this progress. This was a really scary one to code. Let's save that. Yeah. I've been like thinking about it for a long time. I'm sure I'll figure out even better ways to implement this. But yeah, anyways. For now, this is going to be a nice little algorithm. Peace. Good night. Or